as replacement for cotton. Hemp is stronger than cotton, so there's interest in hemp. And I think once the defense started to look into soft goods application, I am sure that the benefit will be realized for composite and defense application like, body armors and vehicle and such. Again, it is lighter fiber than glass, and there is a lot of glass fiber used in defense. And actually automotive as well. In the automotive world, glass fiber is dominating, but you can see some hemp now in on natural fibers in making body parts for the car.
Thank you so much, Professor Abdul Fateh Muhammad Siam.
You're welcome, my pleasure.
Thank you once again. Now, I would like to introduce Dr. Hafsa Jamshed for the next presentation. Dr. Hafsa Jamshed completed her PhD from Technical University of Belgrade, Czech Republic. She is working as Associate Professor and Director Graduate Studies in National Textile University. She is a group leader of Protective Textile Group, working in national and international funded projects and doing research on structures, sustainable composites, and protective textiles. The topic of her presentation is basalt fiber, the new game changer. Over to you, Dr. Hafsa Jamshed.
Good morning to everyone. First of all, I would like to thank you for the organizing this thing. Like, definitely I am the part of the host, and the basic topic for my presentation is today particularly regarding about the new material that is related to basalt. Okay, I cannot do it in the screen sharing mode because it's not working. Okay, can you see my screen? Okay, can you see my screen?
Yes, Dr. Hafsa, we can see.
Okay, but actually I cannot move my presentation. So that's why actually I'm just a bit confused about that. I cannot move it. Okay, okay, I will go it like this. Fine. So the basic topic for my presentation is basalt fiber, the new game changer. I'm working as member of International Society for Basalt Fiber and Composites. I'm working as group leader for protective textiles. So I'm just giving the small information about our group, that we are working with different type of protective textile applications. And we are working with different industry and different educational institutes. These are the group members who are working with me in this group. Hopefully you all can hear me well.
Yes, we can hear you.
Okay, fine. So this is, now I'm coming back to my topic. So this is the small video regarding my work, like generally about starting from my topic.
Dr. Hafsa?
Yeah?
There is no sound of the video.
Okay, but there I have the complete sound. Okay, but
better to maximize.
Okay. But here I
maximize it if it's possible.
Okay, fine. I will just move further from that. It's okay. So basically the above video is particular about the planet, about the world, how we can save. Like, you know, when we were small, when we were in our childhood, we used, yeah.
Can you go into the slideshow move and then try again? Maybe there is some problem earlier, but you can try once again because most of the
Okay,
attendees
fine.
asking for the slideshow. Now make a try
Okay.
again.
Okay. Can you hear?
No, we cannot hear. But I think you continue with the presentation in the slideshow mode.
Okay, fine, no problem. I can go it like that. So,
Okay.
like, when we were childhood, we used to eat candy and we just throw it because we don't know much about environment. And, I have read it somewhere. The greatest threat to our planet is belief that someone else will save it. And we, the process owner of textiles, started to believe it as our responsibility now. Sustainability in textile remind us that loving our planets, our environment, and our, feeling our responsibility towards that is the road to shining planet. And that's what actually in the video that actually I want to show how beautiful we have planet. And if we are not going to care it, it will be destroyed, and we cannot be managed to provide the planet to our children because it's our responsibility to give that planet back to them in a good condition. So this will be the outline of my presentation that I'm going to present today. As we all know, we belong to textile, most of us, and we know textile is everywhere, and especially technical textile that is to some extent, we can say it's a new terminology, but actually we were using it many of things before too. And it has a lot of applications in different industries. So, but when you're producing textiles or different types of things, like we are consuming energy, we have add pollution to the environment and many other things. So one of the key sustainable meters in textile value chain is very important, that metric is sustainable material use. The green materials, the growing environmental problems, the problems of waste disposal, and the depletion of non-renewable sources have stimulated the use of green materials. And the recyclability and environmental safety is also increasing important to the introduction of materials and products. The focus of green materials relate to polymers and materials with an emphasis on reducing the use of hazardous substances in the design, manufacture, and application of products. Basalt, like this is the fiber that I'm talking about today, and I believe it's a game changer in many applications, in technical and in composite applications. Meeting end product specification is a big challenge, especially for industrial good. And basalt fiber is obtained from a dark colored, fine grained solidified rock. It is environmental friendly. It is available in abundant, like in the earth, we have 70% is about basalt fiber. Although all of them cannot be basalt stones, actually, all of them cannot be used as fiber, but most of them can be used as a fiber. And the production of basalt fiber is similar to the glass fiber, but it has quite less environmental effect, especially with respect to recyclability. And basalt fiber is cheaper than carbon fiber and exhibit and higher strength than glass fiber, especially e-glass fiber. So the basalt has actually no toxic reaction with air or water. It is a mineral fiber and it is safe and easy to recycle. It has not contact with any chemical. It is green, healthy, and environmental friendly high-tech fiber. And it is labeled as safe according to USA and EU. And it is known as green industrial material of the century. And we call it collectively 21st century non-polluting green material. Good range of thermal properties, very high strength, high resistance to alkali, acids, good electromagnetic properties, good resistance, UV, good, and many other good properties. It can be classified as sustainable material because we have a huge amount and we can recycle it again and again. So it is widely used in military and civilian field especially. And this is the world market for the basalt. We can see that it is almost growing at the rate of 12% of cumulative growth. And this is very huge amount as compared to other, and especially in Asia Pacific region, it is increasing, its consumption is increasing a lot, especially in construction and many other aerospace and other applications. The production process of basalt fiber is mentioned in this process, how we melted the stones and other process finally. And these are some fabric that we have developed during our work. And this is the actually chemical composition of basalt fiber. and it has mainly concentrated of silicon oxides. Like it's quite not to be very surprising that if you are getting something from the lava mountain, so it should have very good, excellent thermal insulation and fire resistance property, and that it has. It can be used in automotive exhaust systems, and it has very good high resistance to corrosive media, so it can be used for a lot of construction materials, and it can be used in different types of industrial furnace. It has a growing industry, especially in Russia and Czech and east part of that. And this is the protective application of textile. We are working in that, and already people are doing a lot of work in that. And this is a huge amount of that this basalt fiber, it can be fire protective because its melting temperature is degradation temperature is above than 1400 degrees centigrade. So it can be go through a long temperature. It has very good protection, and it has very high stability. So these are also cut resistance gloves, especially with respect to protective textiles. We are also working with some fibers and also with basalt for achieving high resistance. And now we talk about particular composites, because all we know, we have composite everywhere. You'll all the many presenter before that present a lot about composites. I'm not going in detail, but I'm particularly focused on basalt composites. You can see the picture beside that. This is basalt fabric mobile holder. That is my present mobile holder. And it has a lot of applications in technical textile demands according to that. And fiber reinforcement in composite materials are also used for the mechanical properties. Already glass and carbons are used a lot. So, but they have some environmental issues. So for alternative for that, people are searching and people are doing a lot of work in that mineral fiber from basalt, because it is safe and easy to recycle as compared to glass. Because glass recycling is not easy. They have some chemicals. When you go into that, it has black fumes and many other things during incineration. But in basalt, there is no other material. It is single raw material when we are developing fiber from it. And also it is very environmental friendly, and as the world is paradigm shift to the environmental friendly materials. So this is one of the good option. Below are few examples. People are producing snowboard boards with the basalt, and also with the addition of natural fibers like flax and other materials. And this is glass and carbon composites. Like we all know it's a huge market, especially carbon for the auto space and many other applications. But basalt can be replaced glass in many applications. And as we already said, that it is environmental friendly and cost effective components as compared to carbon in some applications. So the major attraction about green composites are that they are eco-friendly, fully degradable, and sustainable. That is, they are truly green in every way. Green composites may be used effectively in many applications. And this is the basic emphasis for the work that I'm going to be mentioning in next few slides. This is a comparison of different fibers that are commonly used for the composites. And we can see that like it is a very close to the glass in many properties, but its melting temperature is quite high as compared to a glass fiber. And its cost is comparable to glass. These are the some applications that it has. It has very good shock resistance. It can be go for ballistic, and it has like when you are going for that, it has other applications. Especially, it has very good compatibility with different types of resin, and it has, and especially with respect to when you talk about different type of manufacturing disposable requirement, it's follow that as compared to glass, as I discussed before, because it has some environmental issue in that compact. Excellent end of life recyclability of basalt, and the capability of basalt fiber to endure continuous heating with a temperature of 460 to along with peak heating up to 1000 make it, in manufacturing of thermal insulation materials especially. So the players in the market are expanding their production capabilities, which leads to increase in demand for products in the composite markets as well as in the construction industry. These are the few examples And like this is muffles for the exhaust system we developed here for the basalt because it has very high temperature manageable and it's have very good insulation properties too. And we are working already on brake pads and side mirrors of the automotive with some industry. So the topic of my research with that, what actually we are doing at present is in the concrete structures. Because in concrete, like if you're using 100% cement, it is not very durable. And if you're adding steel and other materials, although they give the required strength, but after some time, it is a chances of corrosion. Also, due to shrinkage, it may be chance that there is a crack propagation. And it is not a new thing. People are using different types of materials in concretes. If you remember in the villages and in the past, people are making different types of bricks, and even in the houses, they put the grass and many other materials. So different types of fibers at present people are using to avoid cracking, and sustainable energy efficient and eco-friendly construction material is sought around the world. So at present, we are working in some internationally and nationally with some, especially in the PM New Housing Scheme of Pakistan. We are working in the construction material for that. And also with some universities in Pakistan to develop those materials that should be environmental friendly and also energy efficient. Why textiles are used? To bridge the gap that develop in the concrete and also to increase the strength. That's the basic purpose of that. So this is the one of the work that we did. We use different type of natural materials, that is particular basalt, jute, and also synthetic, that is polyester and polypropylene. We have checked their combination with the cement and how they are strong. And from the results, we concluded that the addition of fiber to the cement increased the interfacial bonding. The increase in the bond strength can be attributed to this fact that on one hand, use of fiber in the cement reduced shrinkage, cracking, and also increased their interfacial strength. The result obtained from the tensile test demonstrate that if we are adding basalt, because we develop different type of fabric, woven fabric structure, and if you're using only polypropylene and polyester, that required strength is not achieving. But if we are adding basalt with them, the required strength is very high. So the hybridization of polypropylene and polyester yarn with basalt during weaving can solve this problem. And according to the result, it can be concluded that the accelerating aging test was too aggressive for textile, jute, and polyester because we used cement is basically basic in nature. So after some time, it's the chances that fiber can be degrade. So for that, we also tested that, and basalt and polypropylene are those materials that goes very well as compared to other materials. This is also one other work that we did for this is one of the work of like my MSc student. We developed eco-friendly and energy efficiently building materials. And for that, we add different types of fibers also with the basalt too. And these are the all, especially the sugarcane and the coconut is actually waste fibers. And from the like these are our mixing of that. And then we have the SEM images, how the fibers are inside the materials. And these are the some results, like we have when we are using basalt, our thermal conductivity is very low. So it means it has very good thermal insulation. It's not a go around the temperature difference. Also, we check the thermal degradation, and it has also very good, also the other materials. But as I discussed before, basalt has very good durability in the concrete for the longer run. So we prefer in that applications in that. And the conclusion, the result revealed that the coconut and basalt fiber sample show maximum improvement in the thermal insulation. The thermal conductivity generally decrease as we increasing the fibers. The TGA of natural fibers is quite low as compared to basalt because basalt does not degrade. And we also check it for the 300 degree, but for the particular work, because normally temperature is maximum 50 degrees centigrade. So in that context, all the fibers can go as well, but the accelerating aging issue is the still problem. And we are still working in some mechanical properties for those materials. These are the some works that we are doing with basalt at present. And when we talk about basalt with respect to construction, this is one of the example in Karachi, that is interchange. in that bridge, it was used some fibers material. We are also working with some industries in that. And when we talk textile reinforcement, crude making a significant contribution to the sustainability in the construction industry, while allowing for environmental friendly building construction, because as we told, if the salt is very environmental friendly, if you're using different types of steel, because steel consume a lot of energy, also carbon dioxide, and also 1 kg of the salt can be equal to 9.6 kg of steel. It gives the same strength. So in that context, it's very sustainable because we are using materials. And in environmental terms, since fiber reinforcement do not oxidize, they are well ahead of steel, which will grow sooner or later. And also it can be a big involvement, especially in the world, especially the areas where there are sea nearby, so that the corrosion can be reduced. This is the one example in the world where they use fiber materials. It is not basalt, but they use fiber materials in the Germany, Elbestas, for the near the sea, especially in the sea actually, to provide the required strength. And the major emphasize that it will longer lasting and increase its serviceability. So it's going to be end of my presentation. So the basic thing is environmental friendly textile, a road to sustainability that I hope so we all belong to this planet and we love our planet and we want to save our planet. So we need to work for that together. These are the different works that we did particular for the basalt fiber. These are the few publications of mine and my students that we are doing in particular only in basalts. And at present, I am also a guest editor for the inorganic nanocomposites, and we are expecting many people will be working in organic materials. And that's what actually I believe we need to go green. And basalt fiber is the composites of the future. It's the future of the technical textiles, and basalt will be a huge market in future. And that's what actually. Thank you. And if you have any question, you can ask me now. Thanks a lot. I believe I finish it on time.
Ms. Hafsa? Dr. Hafsa, can you hear me?
Yes, yeah, I can hear you.
There's a question. What about the extraction of the fibers? As we have to heat it at 1500 degrees centigrade for make it a usable material, is there any alternative way?
Yeah, at this time, people are working. There are many methods of developing of that, but you need to melt it. And its melting is about 1500, 1660 till now for the fiber manufacturing. But at present, there is some association working in China with the collaboration of Soviet, in Czech Republic. They are trying to reduce it, but still it's the melting temperature is the same that already I told before.
Okay, one more question. Do you have the idea about the price of the basalt fiber?
Yeah, it's almost $2 to $3 at present, but definitely it fluctuates.
Thank you so much.
Thank you so much.
Due to some technical reasons, our next presenter, Professor Yodong Wang, is unable to present. We are also short of time and it's time for the break. We will resume our session after 20 minutes. Now, I would like to introduce the first presenter of this session, Mr. Zia Salim. He's working as Chief Innovation Officer at Integration Experts. Zia Salim is a technology enthusiast with a demonstrated track record of envisioning, building, and launching new innovative products and leveraging technology to provide unmatched user experience, a data-centric thinker at the core. He enjoys both using data to make better decisions and designing solutions that make it easy and intuitive for others to understand their data. He has a strong understanding of the Internet of Things, data analytics, and artificial intelligence, and how they are revolutionizing the global technology landscape. In his current role, he has designed Internet of Things and artificial intelligence products in the retail, energy, and logistic verticals. He also has extensive experience in large-scale solution design and was an integral part of the team that designed all three BRT's projects in Pakistan. He will talk on using descriptive technologies to improve value addition in textile exports. Over to you, Mr. Zasli.
Thank you, G. Thank you for the introduction. Um, and I am hoping that my screen is also visible to you. Is that correct?
Yes.
Yes,
Okay,
we can.
great. Okay. Once again, thank you for the introduction. So I am going to talk about what we are doing and the areas that we are researching in how to innovate in not only textile, but a lot of industries in Pakistan which have a lot of potential. Over the last so many years, they're still sort of working on very basic and traditional methodologies. Obviously, the topic today is textile, so I'm going to touch upon one specific area that myself and my team have been working on with some good strides and good success so far, and how this can be implemented. What are the challenges? What are the benefits? And how this can be introduced across the manufacturing, the textile industry. So before I go any further, I would just like to tell you a little bit about integration experts. We are primarily known, or my division at least, focuses on IoT and AI specifically, and we develop solutions, our own products in multiple spaces using whether it's healthcare, whether it's manufacturing, logistics, as mentioned. And we have a keen interest in textile as well, because, like I said, there's a huge potential in this industry. It's one of the largest revenue generators for Pakistan. And there has been very little innovation in this area if we compare ourselves to the region. We're the eighth largest exporter of textile in Asia. I'm not going to, I'm sure everybody knows the facts, but I think the key point here is point number three, that we need to use AI for automating repetitive and tedious tasks, which are still done using human intervention today. And there's a lack of R&D in this area, at least at this point, we feel. And we have sort of, I would say, converged our efforts into ensuring that we can at least bring to the table some interesting technologies and some interesting solutions that can add value. Before we go further, I think it's important to develop some sort of a basic understanding of what exactly is AI and what is machine learning and what is deep learning. AI has been around for a very long time. So although it's a buzzword today, but it's been around for a very long time. It's been around for as long as 70, 80 years. It's as simple as using basic logic to mimic human behavior. So any decision-based system based on any sensors can be termed as AI. What we are interested in is the capability, or developing the capability of a machine in this context, an algorithm, which can continuously learn and continue to learn and continue to become smarter based on the data that it acquires. So it's a self-learning or a trained learning process that that basically interests. So when we talk about AI today, or when you hear the word AI today, what you're actually hearing about is, in a lot of cases, deep learning. But obviously, since AI is the superset of machine learning and deep learning, it is used as the holistic term to define this. What objective and what specific area are we talking about? So we are talking about developing a system and machine, and this is something that we have developed. We are testing with a couple of vendors, a couple of customers and partners as well. Is we're developing a system and a machine learning algorithm to detect faults in fabric at runtime using image and video analysis and high-speed cameras. So right now, as all of you are industry experts, you would probably know that detecting faults in fabric over a loom is a very manual process, right? So there is a loom that is being turned, and you have a worker on the machine that is continuously looking out for faults. And obviously, the cost of fault detection increases as in how you proceed towards the stage. So if you detect it at the first stage, the cost is probably a lot lesser. But if you detect it at the time of packaging, or let's say at the time of cutting, then your cost increases, because then you have to traverse back a couple of steps in order to sort of fix that fault or replace that fabric, right? So the idea is that you have a human worker that at every point, what he or she is doing is looking out for the multiple type of faults, hundreds of them. And we were also quite, sort of surprised when we saw the list of faults that you can have, from stains to knots to burls, to a thread probably missing, or a stretch, or any sort of from that huge list. And what they do is then they sort of detect or note down the length at which the fault was detected, and also use some sort of a chalk or a marker, fabric marker, to identify that. And obviously the loom is stopped and restarted a couple of times. And since this is a human effort, there is obviously chances of error, right? So our objective was to use, and since we already have what you see over here, Sensar, this is a visual analytics platform that we have already developed and matured over the last 3 years, with multiple applications in the traffic industry, in the retail industry. So this is another version or another use case that we have built on top of it. So we offer defect detection in fabric using visual analysis. What we are doing is, we're augmenting the worker. What we're saying is we will install a high-speed camera on top of a particular machine, as you can see in the picture. And obviously the AI part comes later. And before that, there is a whole training model, which I'll just explain to you in the next coming slides. And it takes high-speed images, multiple frames, multiple images per second. And it obviously, while it's doing that, we're also taking input from the machine as to the length at which that image, or the point at which that image was taken. And on runtime, this then sort of detects for any faults that have occurred, or been visible at that particular point, or at that particular length of the fabric, and it marks it out and sends that, or notifies someone who is operating via a very simple dashboard or a very simple notification. And at the end of it, when all this has been done, it generates a log telling you exactly what kind of fault was present where. So again, sorry. Yeah, so obviously the underlying technology for this is we're using convolution neural networks, and CNN is basically a method where we sort of apply weights and apply weighted averages to images, so that one image can be identified from the other. And this is where machine learning comes in. This is where that subset of AI comes in, and this is where deep learning comes in, that we are basically training a model, or training an algorithm by feeding it, and the process that we are using obviously right now is supervised learning. So what we do initially is we would go in and we would record all the images with the human log that has been maintained, and then take those images, let's say of a knot, and we would train the system to say, okay, this is how a knot looks like, and these are the multiple variations of how a knot looks like, so that next time it sees one, it is able to classify an image without a knot, and sort of differentiate it from a normal image. How this is done, again, I've tried to break it down. So what we do is we sort of, um, we give an expert report, we give a profile and other relevant details to this machine learning model or the robot. And we give it similar images that you see on the right, which are probably very familiar images to people in the industry, right? So these are different kind of faults, and they're just probably 10 right now, but there are hundreds of them. And we then give every fault a certain name, and we give it a certain weight. So this then is being fed into a network or a neural network, continuously using hundreds and thousands of images. And once we feel the model is trained enough, then we actually put it to the test. So what happens then is that we give it some classification, we give it rules, and we say that, okay, the next time you see an image like that, what you need to do is you need to quickly sort of notify or classify that image as the kind of image that you were trained to classify. So the reason I'm sort of breaking it down into very small subsets is so that yeah, sorry. So that the understanding can be developed on how this works. And based on that, the algorithm then starts giving you a predictive output. So the advantage that we have today and why AI and machine learning and deep learning has sort of evolved today is not because it was not available before. Like I said, it's been available a long time, but today we have some supportive technologies that make the implementation of this a lot easier. So for instance, the main technology that you need is high-speed cameras, and the advancement in imaging in, I mean, a cell phone camera today is 100 times better than a camera we had even up till 10 to 15 years ago, a handheld camera that we had 10, 15 years ago. That is a major advancement, and that is an area that has really helped sort of take a giant leap in this area for people like us and organizations like us who rely on high-speed, accurate imaging. The other is obviously the availability of high-speed compute. So obviously, all these tasks are compute intensive, and obviously, back in the day, getting high-speed compute and high volume storage was a lot more expensive, but today we know how readily available that has become. So again, these are technologies, two major supportive technologies that have assisted organizations like us, and research that has been around for a lot of time to and given us the opportunity to implement it. So currently, just quickly on how this model works and also what kind of advantages that it brings. The re-implementation of this is very quick. So within a matter of a day or 2 days, once we have trained this model, this can be deployed at one single location in a matter of a day or 2 days. So there is not a lot of baggage involved anymore. In some cases, the whole compute can be done on the camera itself. So there are cameras now with built-in processing capability, so now deploying something like this is not a major challenge. You just need to go install a camera, get the angle right, get the lighting right, and you're good to go. Accuracy is immensely high, of course, because we can, the model is trained, and getting relevant data for this is obviously very easy as well, because like we said, we do a lot of work in this space, and getting relevant images to train models is also very easy. Inspection speed is very high, so maybe the the pace at which a human can detect these faults is a lot slower, because obviously humans have limited capability when it comes to compute. But with a model like this, you can basically run run at much higher speeds, and obviously be sure and rest assured that the model will be sort of working with the same level of accuracy at a much higher speed. And obviously, all that resultant is making this whole process time efficient. So this is, again, this is not research anymore. Like I said, this is something we have developed already, and we have tested it as well with a few partners who are willing to sort of work with us in enhancing and developing this algorithm further. Uh, I'm now sort of open for questions. I just wanted to keep it precise. I know I had 15 minutes allotted, but I wanted to keep it precise. So if you have any questions, and I see there are a few questions. I'll just like to. Okay, so I have a question that says, I've seen colored pictures as reference images. Is your solution equally effective for detecting? Yes, it definitely is. Again, so like I explained, it is all a matter of how we sort of train the model. We have trained the model using color images, grayscale, and if we have enough data, if you're able to generate the right amount of data, we can train it for any sort of fabric type and color. What other input data can be used for the neural networks other than images? So obviously, since we work in the visual analytics space, our main data that goes in is images, but if we definitely augment that data using the reports that are generated in the initial stages by the human operators or the machine operators, that is augmented. So obviously, once we develop this, there is a whole testing methodology that goes in parallel as well, where we run the machine learning algorithm along with an operator to see how sort of they have fared against each other. And those learnings are also then passed on in terms of visual and non-visual data. Would you please comment on image size, soft storage devices, network bandwidth for storing and transferring data? So again, network bandwidth for this is, again, since everything is done locally, so all you need is at max one high-speed camera and one probably a high-spec system, which can be placed within the factory or within the premises, that can be sort of connected over a local area network. So bandwidth requirements really don't matter. What does matter is the frame resolution or the FPS of the camera, and we obviously like to work with a camera which is at least 4 megapixel and 30 frames per second. That sort of produces better, much better results. So, and again, like I said, finding cameras with these kind of specifications is really no challenge right now. We can go out in the market and there are multiple vendors available that can give you these specifications. Storage devices, again, so storage is also, honestly speaking, the kind of storage that you get on a regular laptop these days, like 1-2 terabyte of storage, is more than sufficient, for the kind of model that we're talking about. So just want to clarify that most of the compute is usually sort of required when you are developing and testing the algorithm. Once you've developed it, then obviously you optimize it so that it can run on relatively lower spec machines as well. That's the whole idea and the beauty of it. Do you offer a on-loom solution or off-loom? Right now, it's mainly on-loom. And how is it compatible with loom functioning? So if your question basically means that how do we take the input of the loom count or the length count at that particular point, there are multiple ways to do that. If your loom is sort of a mechanized loom, we will have to then retrofit a small sensor that can give length information at the time of capture of image. So, we can, sort of correlate that, and then that data is coupled and sent to the cutting station.
Asking for the presentation and for detailed question and answer session. Now I would like to introduce our next presenter, Mr. Taqarrub Raza Said. Taqarrub Raza Said is working as DGM Technical Marketing Textiles. He will talk on performance textiles. Over to you, Taqarrub Raza. We cannot hear you, sir.
Ji, Assalamu alaikum, and very good morning to you all. Thanks, Dr. This is myself, Taqarrub Raza Said from Textiles, Pakistan. I will share my screen, what I'm going to present today, inshallah. So am I audible to you all? And can you see the screen? The
Yes, we
slides?
can see and it's audible.
Okay, let me start. So basically, our today talk will be on performance and surfaces materials and specialty chemicals, which iTextiles is actually providing to the market, Pakistan market, in the textiles and relevant industry. So iTextiles, basically, first of all, I would like to, due to time limitation, I would like to go through the lecture bit quickly because of the time allocated to me. So coming back to the iTextiles business activity in the market, iTextiles is basically creating value at each step in the textile to deliver the performance based on the consumer experience. And what we actually do is we gather the consumer insight from different perspectives related to performance and technical textiles in the market, and then we convert those consumer insight to the unmet market needs, which is based on the market generation, how it's going to behave, the concepts, means in the woven fabrics, in the knit fabrics, denims, and garments. And then we work on the value chain, starting from the fiber to the final product. So iTextiles is very well connected globally and locally. We are working through the supply value chain partners, including spinners, weavers, dyeing finishing mills, and the garment manufacturers, and with the buyers and the retailers or the global workwear brands. We also create the value chain or the market generation based on the end use applications, meaning the workwear or the military uniforms or the industrial segment, which has been, these fibers are focusing on. And we develop the brand of the fabrics or the garments based on the value in use. And the whole concept is being marketed globally with our partner mills based in Pakistan. And we have another activity, which is the sourcing of different materials and for acting for the global brands as well. So based on the representation of the companies we are offering today in the Pakistan market is based on Invista, which is the world's largest producer of nylons, then DSM for the ultra high molecular weight polyethylene. Then we have Teho Advanced Materials from China, which is producing the aramid solutions. IFF, that has recently been spin off by DuPont for the bioscience businesses. And then Canica for the monoacrylic fiber. We have Corare for the high performance polyuralates and polyvinyl alcohols, and the Outlast from Germany. So coming to the session of which we are actually looking at, based on the statement which I mentioned, we are converting the consumer insights into high performance textile products, which actually means is we are highlighting, or we are coming on to the point where the end use application or the end user from the workwear, from the military uniform, or it's a soldier uniform. So it has to be, there are certain kind of, it's a trade-off between the comfort and the performance. So we are trying to make the mix of these four attributes, which is comfort, durability, protection, and sustainability. So are all the fibers and the technologies and the special chemicals or the membranes, they are actually fit in that portfolio. So who's our target market? We are actually selling, or we are providing solutions, textile solutions based on inherent fibers or the chemical solutions to these home textiles producers, fashion or casual wear, gloves, workwear uniforms, military uniforms or the military gear, then motorsports and the outdoor segment. So what is currently being basically the concepts being used in the workwear or the fashion or the leisure is actually those concepts being driven from the fashion into workwear, or from athletic into leisure. So we are converting the concepts with our partner mills or with the global associates like brands and retailers. So we specialize in building the concept based on our fiber technologies and the chemical products. Then we develop the product, develop the story of the whole concept and the product which we are designed. Then we provide the integral technical support and the online sales activity. I mean, the sales activity that we do with our partner producers. So currently, iTextiles offers a versatile spectrum of advanced and high performance textile materials. So currently, our umbrella for the high performance textile materials comes in the domain of durability, where the end user or the brands are looking for more durable fabrics, which is, as Mr. Mujibullah Khan also mentioned in yesterday's talk, that durability is the new sustainability. So based on that, consumer is looking for more durable and more long life of the products. So we have those solutions available. I'll be coming to those products later in the slide. Then we have flame retardant materials, which is again focus is to protect, have a protective garment or protective fabric for the workers or the industrial workforce, which actually prevent from different flame hazards or fire hazards. We also do the high tensile strength materials, where we are looking for high tensile value fabrics. Obviously, these are the fibers or some of the chemical which actually goes at the yarn or the fabric stage. We have cut resistant materials for high performance gloves that can be blended with different composites. And then we have anti-static fibers. We have solution for the armoring, which we are already doing with defense forces. And the special category is for the special chemicals and membranes. So in the performance segment, iTextiles is currently working on these 5 segments, which is nets, wovens, denims, motorsports, and gloves. I would like to start with the durability concept, which Cordura brand from Investa has been known for last 60 to 65 years. And Cordura brand fabrics are basically produced with nylon Cordura brand qualifying yarn made by Investa. This is produced mainly at the Investa USA plants. And then we have the staple as well as the nylon filament yarns. And if there are different requirements based on the workwear application or the military side or the casual, there are certain grades of it, how we can do it. We can answer those questions separately. As mentioned, in the flame retardants category, we have a range of solutions, FR solutions, which are inherent flame retardant fibers like Protex, New Star, then we have Pararamid Taparan, we have Vectron polyurylate, and the FR viscose and the FR PVA. These all fibers are basically used as a composite with different cellulosic fibers to achieve different European and North American or other Asian flame retardant standards based on the end use application. Then we also doing a lot of research with National Textile University in the segment of performance textiles, where we include the high performance polyvinyl alcohol and which is from Kurara, Japan, and Outlast, which is viscose acrylic thermoregulation fiber. In the segment of cut resistance for the gloves and sleeves and the balaclavas, we have Trosser from DSM, which is under development at a stage, and the Dyneema is known for the cut resistant and for different gloves standard. Then Taparan again from Teho, and we have Vectron from Japan for this special segment. As part of workwear and industrial or military segment, we have anti-static fiber solutions, which is known for performance, which is Beltron and Tamatar Aramid. Now from moving on to the workwear and the protection segment, we have a total solution for the military segment, which means uniform and tactical gear and arming solutions. So iTextiles is currently working with Teho Advanced Materials China for the para-aramid solutions into bulletproof jackets, bulletproof helmets, which has already been working with, especially I would like to mention National Textile University has done a great job with us for performing the research, and now we are in the commercializing phase. Then in the ultra high molecular weight polyethylene, we have Troser, which is from DSM Netherlands, and obviously Dyneema for a very high performance body arming solutions or vehicle arming solutions for the different paramilitary, military, and other civilian security forces, civil security forces. We have those solutions available as of today. In the range of high performance clothing and tactical gear, iTextiles has been developing Cordura microfabrics for the battle dress uniforms or the combat uniforms with our partner mills in Pakistan. And then we have Cordura fabric, which is for the classic fabric for tactical gear, meaning backpack, helmet, carrier vest applications, or the boots. Again, we work with those end producers as well, and with the defense, we are in coordination with the defense forces as well, what their needs are. So we design and we develop the fabrics accordingly with our partner mills. In the inherent flame retardant fabrics, our range includes Protex, nylon, aramids, and FRPVA range for the military clothing. In Outlast, which is a German company being used by NASA technologists for the thermoregulation fiber, or the PCM, is also iTextile is developing with our mills, with our partner mills. In the area of high performance aramids, we have Metastar, which is honeycomb structure used for the electrical, aviation, and transportation industries. This is a recent new product which is being offered in Pakistan. Then Capran high modulus yarns are used in the category for the end use application into defense, subsea cables, and composites. It's a very high denier, like 4,000, 5,000 denier yarns used. Coming on to the specialty chemicals, finishes, and membranes, iTextiles has been successfully working on the specialty chemicals for textile applications, which includes Silvador as an antimicrobial, non-silver, non-leaching technology. We have enhanced solutions for the soil release and quick dry and applications. It's a chemical finish. Then we have insect repellent range, which is more sustainable. Actually, these all the 3 to 4 products are sustainable, highly sustainable chemicals going into textiles for both workwear, casual, home textiles, and military uniform clothing. We have recently developing the EPT membranes for the oil repellent, water repellent applications through laminations. It's under development and it's a high performance product. Then we have another solution for non-laminates, which is oleophobic treatment via Aerodyne technology. And we are also, as I talk about the strength of the yarns through high tenacity fibers, we also working with our weaving partners in Pakistan, which is actually the application of the sizing chemistry to the yarns before taking them into the weaving machines. Coming on to the bioscience materials that we are doing for Pakistan market includes the range of IFF Gen and Core concentrates and the formulated product, which is high temperature, low temperature alpha amylase, bios covering products. These are the peroxide, some of the biopolishes, both neutral and acid, and the lacase enzymes. So is there any question from the house I would like to answer?
Thank you so much, Mr. Takarrab Raza Saeed. There is a question for you. What is actually your business model? You develop prototypes or doing the consultancy?
So, Dr. We are doing both. We develop the prototypes with our partner mills because we have these are the raw materials available with us from different technology partners, and those concepts being built up. And we also work with as a consultant partners to the industry. I mean, if, for example, one of a global brand in the motorsports was looking for a high performance denim for certain strength, then we come up with different solutions that can be blended or mixed to make that fabric. And based on that, those results were actually taken. Yeah, you're right.
Thank you so much. Now our next presenter is Mr. Tahir Javed. He's an engineer by
Thank you so
profession.
much.
He has over 31 years of vast experience and expertise in fertilizer, petrochemical, and power sector. Currently, he is working as a Chief Executive Officer at Hub Power Service Limited. He will talk on future of work, innovation, and innovators. Over to you, Mr. Tahir.
Thank you very much. Assalamu alaikum, all the participants. It's a pleasure to be here, and I'll take you through my presentation, if I can make it work. Okay, starting off with a special thanks to the university for giving me an opportunity, and special thanks to Dr. Yasser Nawab, Dean for NTU, to make it happen for me, and the gentleman who really asked me to come here and present is Mujibullah Khan. One of his employees was presenting just prior to this, and he had made his presentation yesterday. I was looking at the panel, I was looking at the speakers. I think so Dr. Yasser and NTU deserves really a big hand for making it happen and bringing such a big speakers to the forum, talking about various items. So let me get into the preamble as to what I'm going to talk about. In the last few decades, what we have seen is the speed of change, especially on the technology side, has been blinding. Technology, as you must have heard many people, even in this session and have experienced it, technology is touching and changing all aspects of our professional and personal lives. Recently, we went through a pandemic where we were forced to live differently, communicate differently, and be able to get in touch with people in a different manner, which was either MS Teams. And right now we are all connected on a platform, talking to each other, exchanging information. So there are changes which are happening, and changes are happening at a very, very high speed. What impact will such changes will have on us as students, professionals, academia? That is the subject which really interests me, and that is what I research and try to work with. When everything is changing, what is important is to understand, would it change any skill set which is required to be able to compete in the future, be able to work in the future, or maybe survive in the future? And what do we need to do as a person to upskill, or whatever we are doing as of right now is good enough? So let me place my thought process. I understand we don't have a lot of time, but I'll try to see the best I can do. I refer you to two people, which have written on future, and goes all as way back to 1970. So you're looking at people writing 50 years back. Alvin Toffler is a famous futurist. His thought process was the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And as I go through my presentation, maybe you'll find the sequence in a manner where this becomes more and more clear. John Nesbitt was a similarly a person doing a lot of research on where the trends were. So he came up in 1982. The famous book he had was 10 Megatrends. And his methodology for coming up with a trend was to look at the present, or how we reach the present that will anticipate or paint a picture for the future. So this is what I want to place in front of you, a kind of a framework as to what work is. Work is a summation of tools we have and the skills we acquire to run the tools. Okay. So, I mean, let me elaborate a little bit on this, and then you'll start understanding how this equation fits in all sequences. If you go to pre-machine age, where artisans were working, so they had a simplistic tools. They acquired skills which were unique in nature, and there were artisans developed who used to do work, but they were localized. So the tools were simple, skills were much higher in nature, and that's how they were developing. As you move towards more and more complex machine age uh, time frame, like first industrial revolution and other revolutions, you see the tools with which you were performing work keeps on changing and keeps on improving, and the skills have to be tailored and needs to be following what kind of tools are coming in. Like today, I mean, I was listening to Zia. He was talking about introduction of AI, machine learning, on those kind of tools which are coming in. Now the skills have to follow those tools to be able to generate more and more and better work. So, I mean, what we have seen over in the machine age, which is primarily known as the industrial revolutions, starts off somewhere in the 18th century. What we saw was the physical work which a human being used to do, the muscle work, was taken over by steam power and mechanization of production. And you are all students of textile, and you know how we went from hand looms to powered looms and on and on. And that was the first generation of machines which came in. As you go forward in the second industrial revolution, that's where when the electricity came in. And what electricity did was increase the speed with which we could uh, make materials. Assembly line production was came into being, which is being used now. In 70s, which is the third industrial revolution, we started seeing automation, and that automation came in through PLCs, digital computers coming in into manufacturing, into cars, into many areas. It started coming in. Right now, we are in the fourth industrial revolution, and information and communication technologies are at its peak. We're looking at robotics, automation, we're looking at AI, digital twins, Internet of Things. I think so. The next presentation is about IoT. We're looking at big data, biotech coming in. So we have progressed from uh, helping human being do his manual work by introducing mechanization, making it faster by introducing electricity. Then we move towards taking upon some intellectual work and making it be able to make decisions, which was the digital technology started coming in. Now that digital technologies, along with communication technologies, has converted the physical work and is taking over the intellectual work from the human beings. What we see today, I mean, the kind of companies, if I've taken this snapshot of, let's say, 20 years or 25, 30 years back, this space would have been filled with auto industry, like GM, and oil and gas industry, like British Petroleum, Exxon, and those kind of industries. Right now, what you see is all kind of digital industries taking over as the most innovative companies. So the industrial revolution, which you saw, will generate how the which companies will come forward. So our revolution right now, the age we are in, is driven from innovation, big data, and artificial intelligence. You'll see similar kind of companies coming up. So you see Apple, you'll see Tesla, you see Cisco, and Alibaba. Those kind of companies you will see, which are technology companies. What is happening to work at this point in time? We see a dramatic change which is happening all across. Uh, I've picked up data from US. This is a US study which was done on technological unemployment and what effect computers will have on our employment and workforce. What they assess that computerization, which is coming in, will technically replace jobs which are repetitive in nature, which do not need very high intellect, and their guess is this could be as high as 47%. Medium risk are 19%. Only one third of the jobs which mostly relate to human touch, relates to hospitality where the human intervention is required and where high intellect is required, those are the jobs which are going to survive. So there is going to be a huge disruption which is going to happen in the workspace. What is being debated right now, would all these disruption result into enough new jobs which will take over the people who come out uh, mm, of the jobs because of their risk of getting unemployed due to new technologies. So that is the biggest debate which is going on. And I was just listening to Zia Salim and then a gentleman from iTextile. The kind of work which is going on requires less and less manual intervention, more and more intellectual intervention, aided by tools and technology, which is making uh, jobs much more sophisticated and for a lesser number of people. This is something as students, I mean, there is a lot of students and faculty sitting in this session. They need to understand that the speed with which technology is changing forces us to be able to understand how we need to keep our skills together and how often our jobs are going to get obsolete. And that is the key message coming out of it. We see disproportionate increase in the industrial robots, which are coming especially in China and in the Asian Pacific region. And you can just see the numbers, 154,000 per year to 2017 was 281,000. I didn't find data after that, but anyway, I'm assuming that data is increasing. So, so you're getting machines doing job which are manual in nature and disrupting the employment market to a point where you're getting in robots which do not complain. They do not have breaks. They don't take vacations and are taking over the jobs for the human being. So those nature of jobs are changing. Another interesting thing which is happening is what we see productivity is increasing. And for the first time in history, the productivity is increasing faster than the wage increases. And the income which is increasing is for only top 0.1% of the people, which are increasing very fast. And you can imagine people who are at the cutting edge of artificial intelligence, machine intelligence, and other areas which are much more sophisticated. They saw their wages, income going up much faster than the income of other people. What is the message? Message for everyone is that the technology is making a distinction between the intellectual effort required to do the job versus manual. So more effort is moving towards intellectual effort, which is required to do the job, and people who are going to the uh, universities and who are in academic right now or in professions will face more and more pressure to keep on upgrading the skill because I mean those are the kind of things which are making us do our jobs faster, but at the same time is making a lot of jobs becoming redundant. And in your industry, I mean, there were a lot of examples given, and I think so. The gentleman coming after my presentation will give you further examples as how industry is very rapidly changing and is replacing manual work. Just few examples of machine learning where it is going. Uh, mm, these three examples can tell you how it has progressed. It chess, IBM Deep Blue, Jeopardy, and AlphaGo, which is Deep Minds. The difference between all these three is the structured to unstructured learning mechanisms. Chess was a much structured. Jeopardy was somewhere in the middle. AlphaGo is a machine learning computer, which is the Deep Minds, where it learned by playing games, and it is very interesting to go and take a look at where the technology is going. So my takeaway from this slide, primarily for students and other people, is due to rapid computerization, there is a shift in the job market. There are certain kind of skills and jobs which are at high risk now, and they will be either eliminated or reduced tremendously. We will see rapid increase in automation, where there is a replacement of human with machines, and that will become more and more prevalent as we go forward in time. Certain skills will be paid disproportionate to skills which are normal in nature. So as students or as people who are in profession right now, you need to see which are the areas which are going to grow. I'm going to touch briefly on it and then come so that you can get some idea what are the areas you need to be thinking about. Machine learning we have talked about. What kind of a global challenges and opportunities are there? Because these will shape how the jobs look and what kind of jobs we can see in the future. And especially in the last presentation, there was a lot of discussion on sustainability. There was a lot of discussion on environment. So there are areas which we are talking about. Demographic shift. You will find more older people than younger people as we go forward. As we have more people, there is a rising demand. Economic expansion will happen. Hyper-connected Earth, meaning very rapid communication systems are there, and we don't have to travel that much, so it has its own fallout, ecological overshoot. We're trying to live beyond our means, and that's what is happening. Mega urbanization, people are moving from rural to urban, from urban to are coming to urban areas. So there is a huge pressure on infrastructure, resource scarcity, and climate change. What I'm trying to give you a message from here is these are the challenges which uh, we will see in future. But at the same time, these are opportunities. So as you are developing your career, as you are thinking about academics, or you are going in your profession, you need to see which areas are the ones which are rising up, and how do I align myself to those areas. This is my last slide, and the message which I want to give you is the skill which will be needed most is learnability. If you go back to what Alban Toffler had said, that you need to have this skill of learning, earn learning, then learn, and maybe unlearn in your lives multiple times. Uh, at least I belong to a generation which was lucky. We started off with a career. I became an engineer, and we started off with a career, and we had a career which took us to where we are. Many years of service, but the future doesn't look uh, that way. It future would look like a lot of changes where you have to learn and relearn. You need to be flexible in your careers, locations, what you do, and all these things would require you to have adaptability as a skill. The kind of things which might help you in thinking through this thing. Uh, you need to be able to gain multiple experiences so that you can connect your thoughts. So just learning about one system, one area may not be enough. So just saying that it used to happen that way, we used to do that way, may not help you in the future. Experimenting, that would be an important skill to have. Questioning. We are normally told not to ask questions, But the way the things are going, this will become a critical skill you will need. So, I mean, whatever insight we get out is by seeking clarification, asking questions, getting insights, and then making the connections. Observing, I mean, you need to be a deep observer now to look at things, how they're happening, and how the people, products, services, cultures, and technologies interact. And the kind of presentation which I have viewed and looked at it, people are looking from the customer to the product and seeing how they are managing themselves. I was looking at a presentation which was sent to me by Mujib, and he had picked up certain things like what are the physical trends, what are the emotional trends, and what are the trends which are setting in, and how do you match yourself to those trends. So there are psychological trends which are happening, there are global trends which are happening, and you're trying to so the keen observation, keen look at what's going around you would help you. Idea networking, and this is the kind of forums where people are coming across, trying to network various ideas they have, and try to uh, see what is the best way and where the world is going. I'm again thankful to Dr. Yasser and Mujib and NTU for giving me an opportunity. And here I'll stop. If there are any questions or any clarification required, I'll be more than happy to do it.
Thank you so much, Mr. Tahir Javed, for your presentation and the kind words. We have a question. Have you conducted a study that how much labor we can reduce by implementing and improve the efficiency of any textile process?
No, I'm not a textile person. I'm an engineer by profession, looking at power plants. But that is one of the questions which you as a university need to start looking at in terms of the shift which has happened in Faisalabad from where the 1960s labor force was intermediate and where we are. I think so. You will see there is the number of people required to produce the same output have gone down tremendously because they have different tools which they can work with, and they have acquired different skills. So I don't have a good answer for you, but I think so. Textile industry specialists can give you a better answer. But I can say it for my industry, we see a dramatic shift in employment, and that is happening for the same number of megawatt. We are now requiring less and less number of people. So that is what is happening in the industry.
Thank you so much.
Thank you. My pleasure.
Our next presenter is Dr. Awais Khatri. He is working as Associate Professor, Department of Textile Engineering, Mehran University of Engineering and Technology, Jamshoro. He is in charge of Color Research Lab. He will speak on role of Industry 4.0 technologies towards sustainable textile manufacturing in the post-COVID-19 era. Over to you, Dr. Awais Khatri. Dr. Awais Khatri, can you hear me? Your mic is mute. Dr. Awais Khatri, please unmute your mic.
Assalamu alaikum. Assalamu alaikum.
screen. We can hear you, sir.
जी आवाज आ रही है मेरी?
Yes, we can hear you. Please share your screen, sir.
Okay, I'm sharing my screen right now. Okay. Is it appearing to you?
Yes, we can see. Please go to the slideshow.
Okay, can you see my presentation?
Yes, we can see. Thank you.
There is an interruption with your voice. I can't hear you.
Is it okay now, sir? You can hear us?
Yeah, I'm hearing, but your voice is being cut in the middle.
You please start your presentation, sir. We can hear you properly.
Okay. Assalamu alaikum. Good afternoon, everyone. This is Awais Khatri from Iran University of Engineering and Technology. This is the presentation which I'll be talking about the role of Industry 4.0 technologies towards sustainable textile manufacturing, especially in the post-COVID-19 era. So my presentation covers mainly three parts. The major part is about the fourth industrial revolution and its technologies. And the second part is related to sustainability issues in the textile manufacturing and processing industry. And the last portion is what are the benefits of implementing Industry 4.0 technologies towards a sustainable textile manufacturing. This is a kind of introduction. Many people, especially those people working in the industry, are now implementing already a lot of these technologies in their systems, but still we have a long way to go, specifically if we talk about Pakistani textile industries. The first revolution was when the steam power was invented and weaving loom was first invented. It is related to textile manufacturing, and mechanization came into being. That was the first industrial revolution back in 1784. Then second revolution was mainly about mass production, where assembly lines were introduced, electric power was introduced, used in the industry, and it was in 1870. Third revolution was related to automation and computers and electronics embedded machines, specifically if we talk about the PLC control systems in the machinery manufacturing. It's very early in the last century, 1969. The fourth industrial revolution, which has started almost 15 years ago, properly 10 years ago, but it is emerging very fast and everything is being transformed. In fact, our daily life is being transformed into such activities. And it is mainly related to the cyber physical systems and Internet of Things and networks. And it is actually about the real-time interaction of human beings with the machines. In terms of definition, if we say it can be defined, this is kind of little modified definition from my side, and it includes it covers almost all the areas of the Industry 4.0 technologies. It is actually the current trend of automation and data exchange in manufacturing technologies through intelligent networks, such as human resource communication, cyber physical systems, Internet of Services, Internet of Things, cloud, cognitive, and mobile computing. And that ultimately creates a smart factory where every activity, every machine, every process is integrated through electronic devices and through internet and networking systems, where every machine component is connected. and related machine or component via networking creates communication and data information exchange. Now, I do not go in a lot of details about these specific technologies. However, I will be quickly talking about those technologies. Like, for example, this one is about the cyber physical systems from the base of Industry 4.0, which is smart factory. The modern tool systems have embedded software systems and internet addresses which are connected for the industrial Internet of Things activities. And all the machines, all the components within the factory are integrated through such systems. And they are interconnected for their communication within themselves. Information is shared within the machines, within the factory, and within the activities. Products, means of production, and related activities get networked for communication. And in this way, we enable the new way of production, value creation, and real-time optimization. And this real-time optimization is a very important point because this ultimately add up to the economic sustainability of the industrial activities. If we would like to characterize Industry 4.0 in more specific way, then we can say that it is even more automation than in the third industrial revolution, bringing of the physical and digital world through cyber physical systems and enabled by industrial IoT and iOS. A shift from a central industrial control system to one where smart products define the production steps. Closed loop data models and control systems are utilized, very much personalized and customized system of producing products. This is a picture which is showing the 9 pillars technologies of Industry 4.0. It includes horizontal and vertical system integration. Vertical integration includes the integration of the processes and steps within the industry, and the horizontal system integration includes if we talk about the value chain integration. And all that integration is done through electronic devices and the networking using cloud computing or Internet of Things and such technologies. Another is, of course, the industrial Internet of Things. All of these technologies are, by the way, are very much interrelated with each other. And these are the 9 major technologies which are used in the industry, which can be used in the utilized industry. Cyber security is, of course, we come to this in the last simulation, where we can simulate the pre-experimentation, the trainings, and we can see before producing anything, we can simulate the results in advance, so that our time, our materials, our resources are saved, and we can optimize our processes even better. Autonomous robots are utilized in the industry, which includes the automatic manufacturing and processing systems, where they are smartly working without interaction of human beings with the machines, and they are sometimes intelligent robots as well. Big data and analysis is about the information and historical information and the current information to a cloud area, and where all the data, previous data and the current data is saved and compared for improvement of the future activities. Augmented reality is once again to see it's similar to the simulation, to see the virtual realities before doing it actually. And additive manufacturing is about the 3D design models and 3D printing and modeling the products before putting them into the manufacturing field. So cybersecurity is very important, because once we put all the information, all the data to the open sources, open internet sources, so the cybersecurity becomes the major part, because sometimes we have confidential data for personalized product designs and things. So such securities are ensured before implementation of these these all industry 4.0 technologies. So all those 9 categories, 9 technologies can be further categorized into 3 major categories. Number first category is the digitization integration of the value chains. And this includes use of cloud computing, use of mobile devices, including tablets and other mobile devices, and Internet of Things platforms. So these 3 contribute to the digitization integration of overall value chains. The second one is digitization of the product and service offerings. That is, these activities are normally within the industry, within the manufacturing and processing setup. It includes smart sensors, big data analytics carried out through computer-aided softwares and activities. And multi-level customer interaction and customer profiling is also carried out, and augmented reality is implemented in that. The third one is digital business models and customer access. And now this one is a very important activity, for example, to understand the customer demands and to make in-time deliveries also. It includes advanced human-machine interfaces, authentication, and fraud detection. Of course, cybersecurity is also part of that, because this is the interaction of the third-party people within the system. And 3D printing, which is also called as additive manufacturing, as I talked about this earlier slide. Now, these are some example tools and devices which are which which can be used in the industry. These robots are utilized. HMI is human machine interface, which includes the touch screen displays and input and output devices which humans use for operation of machines or robots. Variety of sensors are of course required, and more sensing, more automation is possible. More automation, if we do more automation, it is possible to make it more machine robot controllable, and that can be further transferred to the internet related activities. Monitoring tools, of course, like sensors are important, monitoring tools are also important. Instruments, which are smart instrument, I would say, which are contributing towards the integration of machines to the internet resources. Control systems, of course, these control system, sensor and monitoring were already introduced in the third revolution, but these 3 are important because without them we cannot integrate the digital systems to the machines and ultimately to the internet and cloud computing. So all of these are major example tools and devices which are utilized in the industry. This is another perspective. Now, all those same things are presented in different way in this slide. This says that additive manufacturing, augmented reality, collaborative robotics, data analytics, smart factory or smart products, and machine learning and mobile computing all are the industry 4.0 activities, and the base technologies which are used to conduct all of them are the Internet of Things, cloud computing, RFID, and big data analytics. The major activity now, I am coming specifically to the textile industry because this is related to the implementation of these technologies to textile industry. So mainly these activities are carried out in a textile industry. Number one is material sourcing, procurement, and the second is utilization of utilities, including electricity, gas, water, and steam. Inventory is done, manufacturing, processing, and finishing is carried out, packaging and delivery for shipment is done. So if all these activities are integrated via networking and internet, then every information is readily available for the next process and the previous process, and we can monitor the performance, maintenance, and the time optimizations of all the single activities, even to the machine level. So in a smart industry, all these activities and their data information is connected and integrated through Industry 4.0 technologies to every related activity via internet and networking, and that's the revolutionized part. So if we would like to convert our industry to this Industry 4.0 perspective, so we have to utilize first, what we need to do is we need to convert our each machine, each activity to the digitization, and then we have to connect them to networking and internet. There are various services and softwares available nowadays in market, and various IT solutions are provided for these activities. Many companies are working on that also. So once this is done, though, all the information then can be handy for every stakeholder working in the industry, whether the person is the manager or the external stakeholder, even the customer can access, can follow up the supply chain and the merchandise, the product. I do not go to specific details about all these technologies further, because this is a lot of details in that. Rather, I would be preferring to go to the actual task which I have, that what is the connection of sustainability to this thing. So all these ultimately, okay, I quickly read through this. So autonomous systems includes autonomous robots. Programming allows robots to work automatically. Of course, it enables them to think on their own. And this is something where we can reduce the human interaction with the processes and machines. This contributes towards profitability, productivity, and competitiveness, ultimately, of course, increasing the cost and making the economic sustainability better. Additive manufacturing includes digital 3D design, data, and 3D printing are examples. Component building in layers is possible by this. Augmented reality it is enabled augmented imagery to be placed in front of the real world. Textile based companies, for example, make use of this technology to give customers apparel tries according to the database on size and color. So before it is actually made, it is it is produced through augmented reality, and customers are giving feel of that. Simulation, it is the actual, as I already told, that this is the simulation or intimation of the actual situation, process, or environment, and it is the best suited for pre-experimentation, sampling, and training purposes. Cloud computing includes big storage and central storage management, and processing of data is done using remote servers. It ensures faster production and supply. Cybersecurity, yes, once again, this is mandatory for the protection of sensitive, confidential, and important data, as I already said, including intellectual property, customer, and product information. System integration includes basically two parts. Number one is the vertical integration and horizontal integration. As I've already told, that these integrations are about, vertical integration is about within the factory or the system, which includes from field and control levels to the production operations and enterprise planning levels. And horizontal integration is about mentioned end-to-end value chain, and that is from supplier processes, information flows, IT systems in the product development and product stages to the logistics, distribution, and ultimately the customer level. Big data is about the storage of the information and are making archives of the trends and patterns which are identified during the process, and relationships are built through the information, and those can be used for improvement of the manufacturing units through it is kind of a globalization thing, and it can be the optimization at one industry can be utilized, the optimization of the other industry can be replicated if it is shared with some certain terms and conditions. And this is very useful tool that, for example, if we have any experience of making a profitable manufacturing process or business in a certain way, we can replicate that later on anytime. And all the information is saved as big data and can be used through softwares to analyze the. And sometimes this data can also be used for prediction purpose as well for future activities. Internet of Things is about, I give you one example. For example, it's very common example for Internet of Things. It's like, for example, I have a refrigerator at my home, which is connected to internet, and it is connected to certain softwares and online stores. And my fridge has sensors in it, and it senses what quantity and which kind of food is available and which is not, and it is automatically. And that what happens where anything is going to finish, so it automatically sends message to the grocery stores, okay, please deliver the for example tomatoes or potatoes, and the online orders is placed and it is charged through my card and it is delivered to my home, and everything is automated through this technology, these types of technologies which are called internet. The same pattern can be used in the industry. Machines are automized, these are connected to certain softwares, and of course machine contains sensors and controllers for all single activities, and the information is exchanged within the machine's processes, and whatever is required by the machine is delivered to it, and whatever is produced by the machine is delivered to the next process automatically. So this is how it is done. A lot of effort is being still done. This is still, there's a lot of gap in this particular area and people are working on this. However, a lot of solutions have already been provided for the textile manufacturing industry for various processes. So now this is another list where I'm telling you the role of IoT in managing the enterprise. Automated reports and dashboard and performance of textile machinery or plants generated through that. Online analytics can be done, and quality analysis is also done through that. Performance benchmarking in terms of product or machine can be done. Identification of energy efficiency opportunities can be obtained through these technologies. Reduce downtime by preventive maintenance. Yes, this is once again more important thing. G.
Sorry to interrupt you in between. In fact, we have a short of time. So can you please jump to the conclusion session?
Okay, how many minutes I have?
It's already done. 4 minutes over.
Okay, can I have 5 minutes more?
Yes, okay.
Okay. I come to sustainability. Specifically, if you talk about sustainability have various 6 major dimensions, 3 being the main dimensions. I do not go into the detail of that. I quickly jump to the actual thing. Now there are 3 stages which makes the sustainable textile raw material, which includes the use of land, water, of natural resources, chemicals, fertilizers, and pesticides. Impact of extracting fossil fuels for synthetic fibers. Specifically, textile production includes use of water, energy, other chemicals, and materials. Impact of producing waste, liquid waste, solid waste, gaseous waste. Impact of added chemistries, dyes, finishes, coatings, and ultimately all this go to the effluent and the air. Social responsibility towards workers and communities surrounding and affected by the industry. End of textile is the 3rd stage, that is and biodegradability is important possibility to turning it into new raw materials, and recycling is the new wave. Conservation, I do not go to this slide. Okay, this is main slide, which I would like to talk about. Major issues of the textile industries affecting economic sustainability. Now, these are a few examples, the real-time example which our industries are facing nowadays. Shortened order lead time and rising material and labor costs with reduced profit margins. Demands for quick production and frequent changes in product orders by fast fashion trends. Harmonizing with logistic warehouses, inventories, stores, supply chains, and manufacturing production plans according to the customer demand. Shortage of products or surplus because of unexpected differences between sales periods and lead times. Demand and availability for fast fashion trends. Loss of revenues by outdated stocks of textile products, which normally happens usually nowadays due to their very short lifetime for every season, delayed and short quantity shipments and deliveries to the customer, excessive stock and storage of inventory due to improperly organized logistics. So all these problems, issues can be resolved by implementing Industry 4.0 technologies. So major sustainability benefits of Industry 4.0 are minimum human physical interaction, because I have highlighted that it is the post-COVID era where we would like to have not social distancing. I do not like this word. We rather should say physical distancing. So we reduce the physical interaction of humans when we implement such technologies, specifically after this post-pandemic situations. Processes time and cost is reduced, optimized production and in time quality deliveries can be done, value addition enhancement can be obtained, reduction of rejection rates during the processes is done, lesser consumption of materials and chemicals can be ensured, reduction and optimized use of utilities such as electricity, gas, water, and steam is ensured. Reduced generation of waste can be done through because of optimizations and process improvements, including air emissions, effluent, and solid waste. Safer work environment and better well-being of workers and staff can be ensured through these technologies also. These are three challenges related to employment. Industry 4.0 compels the employees to develop all together. This is about actually when we implement this, of course, the old skilled labor is not that much useful, so they have to learn the new technologies. And of course, when we implement, we have to invest new capital cost and expenditures are there for the implementation of technology. But that is the initial cost. Afterwards, it benefits a lot in terms of, and it gives, its payback period is very short. Privacy concerns are there, and this is the challenge. But of course, cybersecurity is the top priority. We should ensure whenever we implement these technologies, cybersecurity must be ensured for this. Next is Industry 5.0. So we may be talking about this very soon because Industry 4.0 is being implemented very fast, and 4.0 is about the intelligent machines and intelligent processing specifically, and they may replace the human beings altogether in future. And of course, environmentally friendly processes are ensured up through those also. Thank you very much.
Thank you very much, Dr. Awais Khatri. I'm sorry to interrupt you during your presentation, but we had a limited time. That's why I need to interrupt you. We have a question for you. We came across IE, then Lean, and now Industry 4.0. How we as an executor can think in this all with current circumstances? What if we don't?
Ma'am, your voice is not clear.
Let me repeat the question. Can you
Please.
hear me properly now?
Yeah, I can hear you, but your voice is cut in the middle.
Okay. The question is, we came across industrial engineering, then Lean, and now Industry 4.0. How, as we executors can think in this with current circumstances, what if we don't do?
I'm sorry, ma'am. Can you please write your question in the chat box so that I can easily read and answer to you?
The question and answer session in the chat box.
Yeah.
Can you please type your question in the chat box?
Yes, it's already typed.
Okay, which industry you have full implementation of the solution? No, I personally do not know any industry which have implemented it fully, but I have some references to it. If you please email me, I'll email you the few reference industry, but they are not in Pakistan, by the way. And the brands specifically are very much working on it, like Nike and Zara are the example which are very much they have already done a lot of work with that, and I do not know exactly any example in Pakistan though, but I can give you the more list. I give you another example, which is not textile related example. Amazon is another example, which is totally working on this kind of concept, Industry 4.0 revolutionized technologies. So another question is, which industry you have? This is the same question. Make it slide. So this is only the question which I have answered. If it is not clear, then ask me again. I can answer you. And if you would like to know more about those industries which have implemented these Industry 4.0 technologies in full spirit, please email me. I'll reply to you. I type my email here.
Thank you so much for your presentation and the question answer session. Now our next presenter is Professor Frances Bosso. Professor Frances Bosso is working in Gemtex in Sète, France. His research areas include textile composites, plastic impact, 3D weaving, 3D warp, interlocked fabrics. He talked on interesting mechanical properties of 3D warp interlocked fabric for composite materials. Over to you, Professor Frances Bosso.
Okay, can you hear me?
Yes, we can hear you.
Okay, good afternoon for all of you. Early in the morning in France, so I'm happy to be there, and I would like to express my warm thankful to the NTU, the organizer of this conference, and also my friend and colleague, Dr. Yassir Nawab. May I share the screen? Just to confirm that you can see the full screen. Is it okay?
Yes, it's quite fine now.
Ah, perfect. So thank you again for inviting me again to share my research results, especially on the topic of fully warped fabrics for composite material. This work has been done by a PhD student, now he's a doctor, and is hired as a postdoc in a research activity, which is Henri Lanciot. And I work with two colleagues, Dr. Lavanier and Professor Soula. And I supervise also this work myself as François Boussu. It's very hard to pronounce, I guess. So just a few words about where we are. We are located in north of France, very close to major European capital like London, Paris, and Amsterdam, as you can see, and Brussels also. So it's very easy to visit us. On the right in picture, you can see the main entrance of our building, which is an old building, which is built in the end of the last century. And inside this building, it is a textile engineering school. And also there is a laboratory, research laboratory, which is called the Gemtex. And inside the Gemtex laboratory, I'm part of a team which is called MTC, deals with mechanic, textile, and composite structures. So I would like to share some results, and especially the fact that I would like to talk about the context of this study. We are now entering a new area for composite material. I call it the third generation. Just a short remind of the history. The first generation of composite material was done in the 50s and 60s, and it was mainly a black metal approach. It means that there was some metallic part that should have to be replaced by other material, which was composite material, and whatever the solution, the main criteria was the performance and of course a lightweight solution. The second generation of composite material was done thanks to the introduction of more resin and more fibers, exotic fibers with different kind of textile structure inside. And one of the most representative example of this second generation was the use of thermoplastic resin, which is which is now used in most of commercial aircraft like Boeing or Airbus company. And okay, these composite material are still using now. And I should say now we are facing the third generation of composite material where, of course, we have to, if we want to design this new composite material, we have to deal with the performance. It means that we have to take care about the mechanical performance. We have to face the forming, the capacity, the forming ability, and so on. The second criteria, which is the cost, or not only the material, but also the manufacturing cost, which is very important. And the last, but not the least, the third criterion, which is the environmental issue. It's the fact that in the forthcoming years, more and more, and it's not in the future, it's now, and it will be more and more important in the future, the environmental issue, and the fact that we have to recycle, and we probably have to better use some bio-resources. And this is very, very important. And all of our research now are mainly oriented to these three main criteria to build the third generation of composite material. So it's not so easy because there is a lot of, as soon as you add multi criteria, it becomes more complicated to find the best solution. Okay, so my talk will be divided in three main topics, three main titles. The first, I will just give you a brief definition and disadvantages of fully warped metal structures. And we will expect to have some result as the mechanical properties, and especially the last research I've done by Henri, dedicated on flax fibers, and we have a conclusion and perspectives. Just to give you a very quick definition, if you probably most of the audience knows what are the 2D fabrics. They are interlacing of warp and weft yarn, which are orthogonally located in the plane, so it becomes one layer. And the fully warp interlock fabric could be seen as a stack of these 2D fabrics where you have a unique type of yarn, which is called the binding warp yarn. And this yarn binds only in the warp direction. That's why we call it the fully warp interlock fabric. To define this fully warp interlock structure, you need to clarify the position and some parameters as regards the four main key yarns used in this structure. The first, I call it the surface warp yarn. It's not exactly Okay, doesn't matter. They call the surface warp yarn. They are mainly located on the top and on the bottom of the structure, but they also could be inserted in the middle, inside the thickness of the structure. Doesn't matter. This, as you can see on this scheme, you have some red circles. These red circles correspond to a cross-section view of weft yarn. So this is the second main parameters, very important parameters of fully warp interlock structure. The third yarn are called the stuffer warp yarn or the reinforcement warp yarn, and they are located between two layers, and they are not interlinked with weft yarns. And of course, the last one, the most important one, the binding warp yarns in blue color on the scheme, where it links all the layers inside the thickness of the structure. So having this view of how to define a fully warp interlock structure, we have published a general definition of this fully warp interlock. If you're interested, you have the reference at the bottom. And what is important in this structure is that, of course, we try to define the number of layers, the parameters that could define the type of the structure, which are the main criteria X1 and X2, and also some parameters as regards the linking warp yarns, the surface warp yarn, and the stuffer warp yarns. That's why we have split these definition in three main, I should say, matrix to have a very clear definition of these structures. X1 could have two values, orthogonal or angle, and X2 could also have two values, layer to layer and through thickness. So it means that you can find four main categories of fully warp interlock structures. For instance, the orthogonal layer to layer. I will show you that in the next slide. As you can see, these four categories or classes of fully warp interlock structures are represented by the cross-section view showing the evolution of one binding warp yarn in red color and the 3D view. And you can see that, for instance, for the interlock angle and binding T, which is through the thickness, it means that it goes with an angle inside the structure and it goes from the top to the bottom. For the same for the orthogonal interlock O, orthogonal and binding T, it means that it goes directly up to the bottom orthogonally and then link all these structures like this. That's why, so it's commonly well known now among the researchers dealing with this area, and there are these main four categories. And according to that, of course, it gives a lot of advantages. Of course, the first main advantage is the fact that due to the fact that there is these binding warp yarns, we have very improved performance in mode 1 and mode 2 behavior. And of course, compared to stacking of 2D fabrics with no links between these fabrics, then it is very easy to understand that it gives more resistance with these additional binding warp yarns. The second is the fact that probably the stuffer warp yarn located here, I just draw on this scheme a red one, but it could be others, of course. The stuffer warp yarn could help to improve the stiffness and bending rigidity, mainly in the warp direction. And we have proven that also. And one also interesting advantages of this fully warp interlock fabric is the fact that we could produce a near-net shape fabric, and we could also have some different thicknesses, and we could have some variations on the fabric width. And this is very important because if we want to produce and design a new type of architecture that could be easily molded and without any waste, as I mentioned in the beginning, the cost, which is one main criterion to design the composite material. It means that if you are working, for instance, with high expensive yarns like the carbon or graphite and so on, then the waste will be very critical. But There are the pros, there are the cons, there are some disadvantages. During the weaving process, we have seen some fiber degradation. Mainly, these damage are due to this third insertion. Of course, you can see, for instance, a warp yarn. If we extract the binding warp yarn from the orthogonal structure and the warp yarn, the stuffer warp yarn from an orthogonal structure, you can see that there is a lot of crimp. There is a lot of difference of crimp between these two yarns, and of course the fact that there is this high yarn ondulation, it reduces mainly the elasticity of the yarn. The second is the fact that probably sometimes the density of warp yarn is very high, and then there is a lot of friction, yarn-to-yarn friction, and then it becomes very difficult to open the chain during the lack of tension, but also the high warp yarn density. As you can see here, the shade is very difficult here to obtain, then it would be very difficult to insert the weft yarn. There is also the yarn friction. You can see the effect. Well, this is one of our results during the production. This is the paramide yarns, and there is a lot of fibers that create some dust, I should say, and it creates a wet fiber that become very critical during the weaving. And we have also measured that in previous research. It is been shown that 50% of the glass fiber for orthogonal structure have been, the tenacity have been reduced by 50% for glass fiber, 12% for carbon fibers, and so on. And we have also done our own experiments during the thesis of Miss Lefebvre. In 2013, and we have checked, and thanks to that, we have improved our weaving process. Okay, let's move to the results. We have chosen to work with a flax fiber. It was during Europe, not a national project with which is called a flax threading. And we try to design some fluid structure with flax fiber. So you have only use one linear density of flax fiber, which is 1000 pex. We have using only one machine, which is a Rapier Dandier weaving machine. We have designed two types of fluid architecture, the OT and OL, orthogonal for thickness, orthogonal layer to layer. We have chosen one weave diagram, which is tool-free, and we have chosen for all the same, for all of this structure, we have all the time 5 layers, and we have the same warp density and the same peak density on the loom. What we have to check first to see how the bending warp yarn weave diagram influence the mechanical properties. And we have chosen the weft effect, as you can see here, which is a 3-4 effect. And we have designed the jaw effect thanks to the combination of warp and weft effect, as you can see there. And you can see that we have the depth of the penetration of the bending warp yarn is located on 5 layers or 4 layers or 3 layers. That's the 2 parameters we have crossed to design all this first approach. After doing that, we have measured the thickness, and we have measured the areal density of this structure. And from the areal density, we found no significant difference. So it's good news. It means that because we have the same linear density of yarn and the same warp and weft density, we hope that we will have the same areal density. That's what's proven, except, of course, some fiber degradation, as I mentioned before. And as regards the thickness, we could see that using the same loom, we don't have the same thickness especially if we use the weft effect or if we use the jaw effect. The difference is not significant, but we could see that there are some slight difference between them. It means that probably the warp tension or the internal tension inside the yarns were handled differently. Then we have checked the mechanical properties of these structures. And what we have also measured is we have also extracted some, after weaving, we have extracted some warp yarns, bending warp yarns, and we have calculated the warp shrinkage. And what we could see is, depending on the depth, the more the depth is, the higher could be the warp shrinkage. And it's up to 20 or close to 26%, as you can see. So it shows us that, of course, due to the fact that we go more deeply inside the structure, we consume more length. So it's quite evident, but it should be measured. And this, also the bending modulus in the warp direction shows that we have a higher value of the bending modulus, considering the weft effect and the jaw effect. Another result was to study the mechanical properties of this fully warping structure, only the textile structure, and we have done some tensile tests, as you can see on the sample. We have done a quasi-static test, as you can see, and we have tested this OT structure, which is orthogonal 5 layers with a path and depth of linking warp yarn of 3 and 5, with 3, 4, and weft effect. And you can see this very interesting behavior, that it means that the stuffer warp yarn first resists to a certain limit, then it drops, but all the binding warp yarns start to become straight. That's why there is a very long value of elongation after maintaining and after obtaining the different breakage of the binding warp yarns. So, considering this specific effect due to this OT structure, we have also tested then for different depth of penetration, and also the more we have the more we go deeper in the fabric thickness, the higher will be the value, especially for this first peak, of course. Okay, this was the test done on the dry structure. After that, we decide to, of course, impregnate and to make composite structures. And, oh, sorry, I go faster. This was done by one of our partners, which is CMP Composites. And as you can see, this is the image of the rosin infusion with a classical process condition, I should say. And we have impregnated these two, sorry, it's in French, the jaw effect and the weft effect, and also different value of the bending depth. What we have obtained first is the fact that we have checked that, of course, our structure was correctly impregnated. So we have checked the porosity, and for most of them, the porosity is very low, except for this structure, probably due to the process, especially for this structure. As you can see, the fiber volume fraction is close to 42, 43%, and the resin content is 65%, roughly. And we have checked also the thickness, and depending, probably due to the high porosity, the thickness is not representative for this value of OL with depth 4. But anyway, we try to obtain quite the same thickness. And we have also tested in the tensile direction we have done some textile tests, both in warp and weft directions. And as we can see, the initial performance we obtained on dry fabric, we have also obtained on the composite structure. It means that initially we have tested, we have checked that the tensile behavior in the warp direction was the highest for the depth penetration of 5 layers for the OT structure, and we found that it was the highest modulus for this structure. We have also tested these composite components also in the weft direction, and we honestly will see a very frank and significant difference between them, except for this weft effect. Anyway. And to better understand which parameter is really influent, we have used a statistical tool, which is called the PLS regression, partially square regression. And we're trying to explain the mechanical properties mainly by the endogenous parameter, which were the parameter of the process and the product parameters. And of course, thanks to this technical statistical tool, it is possible to define a factor of influence. And for instance, if we want to better understand what happens for the tensile behavior, especially for the modulus in the warp direction, we could see that the warp shrinkage of the Stauffer warp yarn are the most influent parameter, but among the fiber volume ratio, the peak density, hand density, and so on. In the weft direction, the parameters that could explain this behavior, especially the modulus, are not the same. And very surprisingly, the most in the weft direction, the most influent parameter is the hand density. Okay, and we have also done the same approach for the tensile stress at rupture. We try to understand the maximum tensile stress we could obtain for the warp and the weft direction. And again, we saw that the more we go inside the structure, the higher we obtain the value, especially in the warp direction of the tensile stress. We could see also this clearly also in the weft direction. So it confirms that the more we link inside the structure, the better will be the result, especially for the composite component. Okay. Again, we have also applied this statistical tool, the PLS regression, both in warp and weft, and the same parameter, the same main influence parameter, which was the warp shrinkage of the warp yarn in the direction, could explain mainly the tensile stress structure. But very surprisingly, in the weft direction, now the hand density become the lowest parameter. It is influent, but it is the lowest compared to the other. And now, which is not the hand density, which is the peak density, which is totally inverse. So it was very interesting to highlight this. And of course, to better understand what happens. And to conclude, I hope that I'm on time. To conclude my talk, I should say that, of course, only on this project, we have discovered that, of course, there are a lot of influence of the product and process parameter that could help to give some mechanical properties. So it is very interesting because we could tune the parameters to fit to the mechanical requirements defined in specifications, for instance. We have seen that it's not only one parameter which is mainly influent, but it's a combination of parameters that could help to understand what happens in fabric directions, and they are different depending on the directions. And we try to also to investigate more works on the fabric thickness, of course. the fact that we could, we have only test 5 layers, but we could check what happens if it's thinner or thicker. Probably we could obtain 10 or 20 layers of weft yarns, so it means a higher thickness. And also to check different linear density of flax yarn. So it means a lot of research to do and to understand what happened exactly. So I'm very happy to share these results with all the audience, and I will be very happy to answer to your question. And I think I could read the question, as I understand, on the chat.
Thank you so much, Professor Francis Bosso. We have a question for you. Can you hear me?
Yes.
3D warp interlock fabric has good bonding properties. These are due to the fabric structure or due to the fibers?
Both. Of course, I show you the latest results using the flax fibers, but since now more than 6 years, anyway, a certain number of years now, we have also tested the yarn, a different type of yarns, like e-glass. We have tested armad yarns, we have tested carbon yarns, we have tested high modulus polyethylene yarns, we have tested hemp, we have tested sisal yarns and so on. So we try to, most of the time, we try to check for the same architecture, and depending on the raw material used, that if we recover the same behavior for all these architecture, which is not which is quite the same sometimes and not in others, but depending on the initial value of the yarn, it gives you more resistance or less resistance in these different directions. So what is interesting to do when you are using that kind of 3D structure is the fact that it is possible you have a lot of parameters and you can tune them to exactly respond to the mechanical stress depending on the specifications.
Merci beaucoup, enchanté. Our next presenter is Professor Mehmet Karahan. He is currently serving in Uludağ University, Bursa, Turkey. He's working on technical textiles and composite materials. He will talk on damage initiation and progression in 2x2 woven carbon epoxy multi-layer composites. Over to you, Professor Mehmet. We can't hear you, sir. Please unmute your mic, sir.
Can I share my screen?
Yes, you can share. We can hear you now.
Yes. Okay. Did you see my presentation?
No, not yet.
Sorry.
Yes,
now okay?
Yes.
Okay.
Go to the slide mode, please.
Yes. Okay. Good afternoon for all. My name is Mehmet Karahan. I am participating from Uludağ University, Turkey. And my presentation about mechanical properties and damage investigation in woven carbon epoxy multi-layer composite with different fiber volume fraction under uniaxial tension. And as you can see, the content of the presentation addresses the issue of damage in textile composite in general, and reveals the experimental result, includes the X-ray, acoustic emission, strain mapping, and micro-inspections depend on fiber volume fraction variation. Damaging composite laminates subject to tensile load includes interlaminar cracks lying along fibers in the plies, interlaminar cracks or delaminations formed by local separation of plies, fiber matrix debonding, and fiber failures. The mechanical properties and the development of damaging composites materials are closely related to their internal reinforcing structure, which is determined during the manufacturing of the fabric and the processing of the composite. The damage phenomena in textile composite is different from those in unidirectional laminates composites because of the yarn crimp and the interaction between the interwoven interlaced yarns.
Can you hear me, Professor?
What?
Sorry to interrupt you. In fact, you just changed the mode of slideshow.
Yeah, sure. It involves processes and parameters on different scale levels, including macro, meso, and micro levels. Damage initiation and propagation properties in woven composites vary depending on construction and yarn crimps in the fabric. The most important factor affecting the damage initiation and propagation properties of these reinforcements has found to be yarn crimps in reinforcement. Textile reinforcement structure and fiber volume fraction affect the yarn crimp in any reinforcement directly. And table shows the parameter of the studied 2x2 twill carbon woven fabric and the carbon fiber used in this study. Some main properties of materials. And these figures shows the WISE-TEX geometrical modeling of 2x2 carbon woven fabric used in this study and real carbon fabric. For WISE-TEX modeling, yarn cross-section sizes taken from a cross-section of each composite material manufactured in different fiber volume fraction were used in establishing the WISE-TEX geometrical models. This figure shows how the yarn cross-section sizes were taken from the cross-section of composite material. And these models were established according to the placement of the carbon fabric in the composite material. Table shows the result for WISE-TEX geometric models of composite sample with different fiber volume fraction, yarn cross-section and width size, as well as local fiber volume fraction in the yarn, vary depending on variation in the fiber volume fraction in composite materials. Fabrics used in the production of composite materials were cut into 400 by 400 millimeter traces in the warp directions. The fabric was balanced and had identical fiber volume fraction in the warp and left directions. Therefore, the samples were prepared only from fabrics cut in the warp direction. Composite plates were produced using vacuum-assisted resin transfer molding equipment. And composite samples having different fiber volume fraction were produced with the same fabric and resin as well as the same equipment under the same lab conditions. Main production parameters of composite samples were given in this table. Tensile tests were performed on universal tensile testing machine. The samples were cut out of the composite panels in warp direction using a diamond cell. Glass epoxy composite tabs were stuck to the ends of the samples using epoxy resin. The specimen length between the tabs was 120 millimeters. The middle portion of each specimen was painted with a black and white random speckle for strain mapping. A LIMS camera took images of the black and white painted region at a frequency of 2 Hz. The first image, which was taken as soon as the test started, showed the non-deformed stage. The local displacement and strain data were established by comparing subsequent images to the first image with the software. Two acoustic emission sensors, which were placed at the boundaries of the gauge length region, allowed each acoustic emission event to be recorded and related to energy and corresponding applied load. A series of tests were conducted for each sample type. First, 8 samples were tested to failure to determine the ultimate stress and strain. Next, characteristic damage threshold strain values, epsilon minimum, epsilon 1, and epsilon 2, were determined based on acoustic emission records. Then, 4 samples for each type were tested up to epsilon 1, epsilon 2 is the level at which damage has significantly propagated. 4 additional samples were also tested for this level. Finally, the samples tested at epsilon minimum, epsilon 1 and epsilon 2, were used for microscopy and X-ray examinations. To investigate the cracks, X-ray radiography was carried out with the equipment and software to improve the contrast of cracks in the X-ray images. The loaded samples were immersed in a diode penetrant bed for 44 hours before X-ray inspection. Apart from the observation during loading to failure, several additional samples were loaded to epsilon 1 and epsilon 2, after which the tests were stopped. Then these samples were cross-sectioned and polished, and the crack patterns were studied with an optical and scanning electron microscopy. The core of investigation was formed by the difference in fiber volume fractions. So 2 methods were used for the detection of fiber volume fraction of composite samples. In the first method, the fiber volume fraction was calculated depending on plate thickness. That's a calculation method. In the second method, the fiber volume fraction of composite samples were determined by Burnoff method. In this method, fiber content was evaluated on the basis of weight differences of the samples before and after burning of the resin and heating of the residue at high temperature until constant mass was reached. The result of both methods were very close to each other, as you can see from the tables. Yarn and textile are not entirely homogeneous. Stipulated by the interaction with the other yarns, the local fiber volume fractions varies within the yarn. There is a distribution of the fiber volume fraction in the lenticular yarn cross-section of woven composites. This variation within the yarn especially increases due to layer nesting. Hence, the fiber volume fraction distribution appears to be an important parameter for the location of damage initiation. Therefore, it is important to determine the local fiber volume fraction along the yarn. There can be some method to measure the fiber volume fraction along the yarn. In this study, the fiber volume fraction was measured by microscale method. Fiber volume fraction inside the yarn was calculated with a formula, as you can see in the slide. The fiber volume fraction was obtained from core region where fiber density is higher and edges where fiber density is lower separately. The fibers in the images shown in figure were counted. The fibers cut by the image edge were counted if the visible parts was more than a half and discarded otherwise. When the layers are compressed together in the mold during the composite manufacturing, the hills and valleys of two adjacent woven layers nest one into another. The same effect can be expressed as an increase of fiber volume fraction of laminate compacted under a given pressure with increasing number of layers of the laminate. Nesting of the layers in a laminate affect the damage initiation and progression. This slide shows cross-sectional views of the sample with 3 different fiber volume fraction. The region in the dashed circle in figure B shows the nesting effect of the weft yarns. As fiber volume fraction increases, nesting effect occurs. These effects result in yarn flattening accompanied by crimp reduction in crossing yarns. Tensile test results given as a diagram of stress and Young modulus diagrams with strain for work directions for each fiber volume fractions. Stress strain diagrams obtained for 3 samples having different fiber volume fraction have similar features. Although the diagrams are initially linear, they tend to show a slight nonlinearity as the imposed strain increases. Table shows 3 different values of Young modulus for each of the samples due to nonlinearity of the stress strain curves. These values are computed over the initial, middle, and upper range. The Young modulus values have been determined from the stress and strain data for equal length strain intervals with a formula. Although the degradation of Young modulus is very slight within the range, it decreases after 0.3% strain. The damage propagated more rapidly after this value and ruptures occurred in fibers and yarns in composite materials. In addition, initial cracks propagated significantly and deepened. A decrease of approximately 16% in the Young modulus occurred from the beginning of the test until the ultimate failure occurred. Characteristic of the stress strain curve were not affected by variation in fiber volume fractions. The same trends were seen for all samples. In addition, the Young modulus gradually decreased as strain increased for all fiber volume fractions tested. The Young modulus increased monolithically depending on increasing fiber volume fractions. The Young modulus calculated through the TextComp software for the composite samples are very close to the empirical data. The highest deviation between the results is 2%. This demonstrated that if geometrical modeling of fabric construction is performed based on sizes from composite cross-section, then the result will be reliable. However, deviations were higher between empirical and theoretical data. The data when the Young modulus was calculated using rule of mix. This can be attributed to the fact that the contribution of transversal yarns in the fabric to the construction is neglected in the rule of mix. Normally, these values are expected to be higher by 1 or 2 gigapascal due to contribution of transversal weft yarns. These results show that the measured and calculated values are well correlated. The energy of acoustic emission events and the associated loading levels determine the dependence of the cumulative energy of acoustic emission events on the tensile strain. We can, according to these observations, the following characteristic measures were determined for each samples. The acoustic emission threshold strain is epsilon minimum, at which the first acoustic emission event occurs. The first damage initiation threshold strain is epsilon 1 at the first increase in the slope of the cumulative acoustic emission energy curve. And the second damage threshold strain is epsilon 2 at the second clear on the acoustic emission cumulative energy curve. The damage threshold are an important property of composite. Change in the rate of acoustic emission event accumulation indicates a switch to another damage mechanism. And you can see the differences between epsilon values depend on the fiber volume fraction variation. Acoustic emission events occurred at epsilon minimum values at which the initial damage was recorded at a low energy level. Generally, smaller microcracks took place at these levels. Such cracks occurred individually at the fiber and matrix interface. The cracks were not yet propagating in the transverse direction. Variation in fiber volume fraction had no effect on the occurrence of the cracks. Some observations showed that these cracks occurred as fiber matrix interface debonding. Transversal cracks were not seen in the sample loaded at this level. According to acoustic emission diagrams, some high energy events occurred at epsilon 1 level. Small transversal crack occurred in the samples loaded up to the epsilon 1 level. Microscopy image, X-ray images of transversal cracks that occurred at epsilon 1 level taken from the surface and cross-section of the sample. It is not easy to detect the exact location of crack initiation using X-ray observation. However, microscope observation can provide insight into the location of crack initiation. These cracks occur inside the weft yarns and they do not propagate across the whole width of the sample at this loading level. In addition, these cracks are only in the form of matrix cracks. Fiber ruptures have not yet occurred in the cracks at this level. The most important reason for this may be the fact that this loading level is lower than the required for fiber rupture. X-ray and microscope observation showed that the variation in fiber volume fraction had no effect on the characteristic of damage that occurred at the epsilon 1 level. The cracks that occurred at the epsilon 1 level have the same characteristic in all three samples. The energy level of acoustic emission events that occurred at epsilon 2 level was high. Microscope observation conducted at the epsilon 2 level showed that the cracks propagated across the width of the sample. These existing cracks propagated and became deeper at this level, and additional cracks were formed. The cracks initiated at this level were both of the fiber ruptures and matrix cracks. Variation in fiber volume fraction has no effect on the propagation of damage at this level. The damage achieved saturation at the epsilon 3 level and no further cracks occurred. However, the existing cracks became deeper. This indicates that saturation was achieved after the epsilon 2 levels. This figure shows X-ray and microscopy images of propagated cracks taken from the surface and from the cross-section of samples. This figure shows that the damage occurred as delamination and fiber matrix pull-out between layers and ruptures or debonding of yarn bundles at further strain levels. Figure D shows the lamination cracks, fiber matrix cloud, and significant ruptures in yarn bundles. Yes?
We are actually running out of time, so if you conclude this.
Okay, I'm finishing now. And you can see epsilon minimum, epsilon 1 and epsilon 2 damage modes in woven composite laminates. It's impossible to determine exactly where damage occurred in material. However, microscope observations suggest that damage was initiated close to yarn intersections. However, it's clearly seen that the strain distribution was mainly concentrated in the regions where warp and weft yarns interacted. You can see from the strain mapping images. The images show that the maximum strain concentration zones occurred on the warp yarns at the surface and in the resin zones between the warp yarns. The minimum strain concentration zone occurred on the weft yarns at the surface. This is an important conclusion. And the conclusion, stress strain curve characteristics were not affected by variation in fiber volume fraction. It was not meaningful to evaluate the acoustic emission events occurring at epsilon minimum level as a characteristic damage initiation parameter. The strain range within which the initial damage was recorded and damage was completely propagated decreased as fiber volume fraction increased. Variation in fiber volume fraction had no effect on the damage modes, location, and propagation characteristic of the damage. And thank you for your attention.
Çok teşekkürler hocam. We have a question here from the audience. Actually, what you did to avoid the static charge on various parts of spinning and weaving machines when you process this carbon fiber. So have you used any finish to avoid the static charge?
No. We have used a ready carbon fabric, not manufactured by us.
Okay. Teşekkürler hocam. Güle güle. İyi akşamlar.
Ben teşekkür ederim. Thank you.
Second day of 6th International Conference on Value Addition and Innovations in Textiles has come to an end. We have lunch break of 30 minutes. We'll rejoin you right after the break for the next session at 2:30. Thank you so much.
Thank you.
Welcome back, ladies and gentlemen. Welcome back. We are really about to start today last session, and previous two sessions and yesterday's sessions were very informative. All the speakers, they have shared their research and their expertise, and these all were very good and very nice for all the listeners. So the feedback of yesterday's session and today's sessions on the social media, it was surprising and it was good. So today's first speaker, now this session's first speaker is Dr. Tanveer Ahmed. Dr. Tanveer Ahmed, can you listen me?
Yeah, I'm here. Can you hear me? Am I audible?
Yeah, thank you. Thank you. Dr. Tanveer Ahmed is working in US Pakistan Center for Advanced Studies in Water, established in Mehran University of Engineering and Technology. And he will talk on textile wastewater treatment and its reuse. It's a hot issue in textile industry. And I think Dr. Tanveer Ahmed will give us very good solutions for these wastewater treatments. Dr. Tanveer Ahmed, please.
So can you see my slide?
Yeah. That's nice. I think you can start now.
Okay. So thank you. Thank you for allowing me to participate in this conference and give my views on one of the projects we done with Al Rahim Textile Industries. So we had a funded project by USAID, and there was a different name of this project, but for the theme of this conference, I entitled as Industrial Wastewater Treatment and Reuse, and it's basically a comprehensive case study of textile processing industry. Myself, Tanveer Ahmed, and I'm working here at US Pakistan Center for Advanced Studies in Water as assistant professor. So this is my email address, and later I will also share the project copy of this technical report of this today's presentation. If someone is interested to reach me or to want to have a detailed insight on the discussion, what I will pursue today with this presentation. So this is the presentation outline. So we will start with some of the overview of textile processes, and then with some of the objectives of that funded project, which followed a case study. And then we will discuss how we can develop some of the water management systems inside the processing unit. Then we will move to the other hot topic of today's textile sector, because in Pakistan we have the water shortage, and now most of the industries are focusing, because also the customer demand, foreign customers, they are demanding to have a wastewater treatment unit and reuse their effluent. Then we will have a close insight on the RO membranes and operations, and then the conclusion. So I will start with textile processes. So I assume most of the audience here, they already know what textile processes are. So basically we have a sequence of processes. We call it wet processes because they involve water as a medium to perform all the activities, most of the activities in processing and finishing unit. So as you can see, we have a gray fabric, which we received after weaving. So cotton, most of the processing industries in Pakistan, they are cotton-based industries. So the cotton natural color is something yellowish because of some of the natural fats and natural colors originated from some of the amino groups. So we need to bleach it first, then we need to dye it or print it, and then we need to finish it. So in principle, what we are wearing as a fabric, it's finished and processed fabric. But in textile processing term, we have a series of operations and there is a lot of consumption of water, energy. So the story is very complicated and there is a usage of many chemicals there. So every single shirt or single object, textile object we are using or we are wearing, they have a water footprint along with the carbon and energy footprint. And water sector is considered as the most polluting sector around the world as an environmental pollutant sector, because we have one side we are consuming many energies on these processes. On the other side, we are also having many emissions and water pollution. So the effluent from any industry, textile industry, is very concentrated with dyes, with many metals and all other organic compounds. So as you can see, here is a sequence of continuous process machines. Like so my colleagues here from textile background or processing background, they will be knowing what is singeing, desizing, and what is discovering and bleaching, and what is mercerizing and pedesting dyeing. But for the general public, I wanted to share that these processes are very important if we need to dye the fabric. So first we need to improve the absorbency or the characteristics of the gray fabric or yellow fabric which receive naturally. And for that, we have jumbo jet machines. Like in textile terminology, they are known as the Titanic of the textile processing unit, because these are very long machines. Each bath filled with much amount of water, and they are supported with many energy inputs in form of water, steam, and all other things. So the fabric inlet or the textile material inlet is from here, and they get processed from this processes, from water bath, steaming baths, and then they will finally end here. So these machines are very continuous. They have a high productivity and they have a high water emitting rate. Lot of water being consumed and polluted from these machines when the water leaves these machines. Similarly, on the other side, we have exhaust processes. So here we have a continuous machine where the fabric is getting inlet and it is exiting the machine, and it is directly processed or bleached or dyed. But here, a batch or lot of 800 kgs or 1000 kgs of the textile material is to be continuously processed until we achieve the desired output. And output could be the bleaching of the fabric, dyeing of the fabric, or finishing of the fabric. So we have different exhaust processes. These machines have low production rate than the continuous machines, but their pollution is way concentrated, because this bath, when it is being continuously treating with the chemicals, this fabric, when the water or the concentrated or heavily composited water will leave from this machine, it has a high concentration of BOD, COD, and other coloring particles, components. So there was one study done by Cleaner Production Institute funded by Netherlands. It leaves some statistics which is very necessary to consider while we are focusing further. So we have around 80 to 200 liters per kg fabric processing. And most of the current practices, we have a wastage of 25% of water. We are using it in excessive amount. And 10 to 15% could be readily managed through certain on-site practices. And in Pakistan, most of the textile sector, they don't have any wastewater treatment facility. So that's a hot issue now being when we are considering a sustainable textile innovation in our industries. So now most of the industries are focusing to treat their water with the zero liquid discharge theme, which is governed by the customers from outside like Levi's, Zara, Target, JCPenney, and Walmart. So with textile wastewater classification, some of the waste composition which is hard to treat, mostly colorants and all the organic compounds, because they are in dissolved form. And they are also toxic to some of the microbes which are performing any biological activity. And hazardous compounds as well, like chlorinated and metals and non-biodegradable VOCs. So they are very hazardous for our environment. And some high volume amount of textile wastewater from continuous and exhaust machines with loaded alkalis, salts, and acids. And some other amount which is in dispersible form, in emulsion or undissolved form. This could be pastes, pigments, lints, and greases. So all these are very hard to treat and hard to manage. And in composition, all these processes generate a high amount of COD and BOD. And also the textile wastewater processing sector is known to be alkaline in nature because of use of the alkalis and dyeing and mercerizing and bleaching machines. So, and also we have a suspended and dissolved solid load leaving from the textile wastewater processes. So Yunus Textile Mill in Karachi was the first who introduced the wastewater treatment and reuse adoption in their industry in 2014. So they have all these facilities in which they have the activated sludge return process. And they are also a MBR unit and RO membrane unit. So they are recovering around 65% of their water with 35% concentrate leaving in the drain. So we have some other examples in Karachi. Now they have initiated this wastewater treatment approach, and they are reusing their wastewater. One of the industries, Artistic Fabric Garment, Artistic Milliner, Al Rahim Textile Industries, Al Karam, and Gul Ahmad. So what we did in our project, this project is, I already mentioned, funded by the USAID. So we had these key objectives in which we estimated and managed water consumption of every textile machine, every textile process. And we also identified some of the on-site wastewater recycling strategies. Why to leave effluent towards the wastewater treatment plant? Why not to treat it, or why not to handle it on-site within the machine? So we designed and integrated some of these systems. And also we explored first, then we configured these things within the machine. And also we analyzed the overall single process composition of the wastewater released from every process and a combined wastewater effluent composition with all the alkalis and BODs. So, am I audible? So the fourth objective was to design the operating conditions for the wastewater treatment plant and RO operations. So Al Rahim is a big industry with the largest wastewater treatment plant and vertically integrated setup from spinning to the weaving and then processing and the garment. So the unit we worked, they were focusing on the textile towel processing. So the nature of project, we did some of the fundamental research and some of the industry-driven research as per their need. So their need was, their plant was new. Their need was to design the operating conditions and maximum recovery of the reused water. So we did some applied research with this funding project. So what we did, this is the schematic flow of all their machines. So they have mixed setup. They have the continuous machines and exhaust machines for every single process. So what we did, we analyzed the standard water composition, which is ongoing, and we analyzed with the benchmarks given by some of the other global benchmark or cleaner production agencies. They have assigned some of the standards that this process should not go beyond with this amount of water consumption or energy consumption. So we compared these consumption rates. So we also explored the on-site water reuse strategies. And we also analyzed the wastewater quality from each process. Then what we did, we also analyzed the composition of the wastewater in a mixed form, which is being leaving towards the wastewater treatment plant and RO membranes for an integrated, intensive biological, chemical, and physical treatment. So this water management system or water efficiency improvement in our project, we started with the developing the water management system inside the processing unit. So before starting, we should be knowing the adjusting the actual water process requirement, and also there should be a goal that we adopt and manage the on-site water reuse. And we also adopt some of the cooling water and steam condensate. So these things I will explain in later slides. And then the maintenance, which is related with water, is very important in textile industry because we can't afford the leakages and the troubleshooting of the water flow meters, because if we can't maintain these things, they will be leaking water in excessive amount. And also water consumption can be controlled through chemical modifications by using some of the effective chemicals and degradable chemicals. So to know and adjust the water requirement, we understand all the water inlets of the machine, and we designed Excel, MS Office Excel support program, in which what we did, we put these inputs, and from these inputs we have one side a standard consumption and one side the reading which is coming from the flow meter. So we will be able to analyze that which machine and which process is consuming more water than its actual requirement. So let's an example of bleaching machine. It cannot consume more than a 20 cubic meter with the production of 1500 kg bleached fabric. So if the consumption can go above 25 or 30, so we will be wasting some of the water because which is not needed. Similarly, we design some of the wastewater balance and requirements and the inputs and models for dyeing machines by using the same technique. We have the water inflows and the steam consumption inflows and fabric production and the processing, particular process which is ongoing on that time. So with that, we have an example of pad steam dyeing machine. That pad steam dyeing required a 17 cubic meter. If the consumption go beyond, then we need to do something with the maintenance or with the some of things of the automation of water. Similarly, for exhaust dyeing process, the liquor ratio is very important. Means for every 1:6 suggest 1 kg towel needs 6 liters of water for processing for each single batch, each batch cycle. So by calculating that for every kg, if we need to load the water for bleaching and then the dyeing and the final washing, then the actual consumption could not go beyond 30 cubic meter. And this is equivalent to around 1.5 water tankers if we are considering a whole exhaust dyeing process. So, and some of the loading can be reduced by considering these aspects, because what is happening now in textile industry, they bleach, they neutralize, and then they dye, then they neutralize again. So what we can do, a fabric could be wet already with initial loading. So we can play with the liquor ratios in washing and neutralization cycles by reducing the liquor ratio to 1:3. In final washing and neutralization, this could save up to 3,000 liters per lot. This is a simple step of just with the fractions and calculations of the liquor ratios while we are loading our fabric. Similarly, for water-related machines, we have to check the flow meters and we have to compute the water balance on regular basis. And then we have to assume the major changes of root sequences. Like if we need to perform the finishing after the printing, then we don't need to put it before the printing or finishing. So we need to route, or if we are dyeing a continuously red shade of the fabric, and lot is big, so we can process it for the whole day, not to prepare the machine for red shade, green shade, and yellow shade separately. So this is a process route sequencing basically. So with some of the strategies we can adopt, what we can do, the washing, the post-washing stage is very clean stage of the water, which is being used here and generated at the end. So we can screen out and we can reuse this water in the pre-washing zone. So this can save up to 8 cubic meter of water. As you can see, these configurations are already given by the machine manufacturers. If you purchase a machine from Banniger and Goller or other machines or other manufacturers, they already have these systems. But what happened in textile industry, these systems got chalked and were not being regularly monitored. So the water is being wasted, but we need to maintain them in every shift for their proper functioning. Similarly, for singeing dyeing machine, we have the roller where it's being heated and we control the lint of the protruding fibers of the fabric before going for any process. So we can collect the water is being cooling this roller separately and we can restore it for usage. Like here an example of singeing machine at Al Rahim Textile Industry. Before they were wasting around 1,000 gallons of water. But after this step, we recovered this amount of water by recovering it in the separate pump. And this pump will feed this to the main storage tank of water from where we are pumping. So with the condensate, basically condensate is the steam condensate. We have a lot of usage of the steam for heating of the bath and all the steamers. So what happened when this steam go for any processing, it become condensate and it need to be recovered and collected and should go back again in the steam boiler to conserve water and energy. But what happened in most of the textile industries, this condensate recovery is mismanaged and you can see this water is getting drained. The other concern is this water is 90 to 95 degrees centigrade hotter. So when it mixed with the effluent, it make the effluent more with the more temperature. Similarly, you can monitor the drainage moving from each chamber and the manual valves remained open. And you can also monitor water flow meters if they are tuned and well configured. And if you can also monitor some of the water flow meters and water controlling valves, which control water when water is needed, and they become shut off when there is no water needed in the machine. So with these chemical modification, with these process and chemical modification, we had many savings in the Al Rahim textile industry. Previously, their consumption was 14 lakh gallons per day, but now their consumption is reduced to 11 lakh gallons. So these things are very visible when you adopt them, and you can compare with the statistics which was going on previously and after these modifications. So now after doing these activities at the floor, at the processing unit, we came across to identify some of the exploring on wastewater treatment plant. So most of the textile industries, they are running on physiochemical biological treatment. They have these aeration basin and then the secondary clarifier. So this cleared the 5 minutes.
Dr. Tanveer, please conclude. Just we have shortage time.
I'm concluding in 2 minutes, 2 to 3 minutes.
Thank you. Thank you.
So this is the process sequence of wastewater treatment plant. So now they have if we have a membrane integration, we can reuse this amount of water, which is partially treated after this biological treatment. So as you can see, this required a regular monitoring and to know the compositions of COD and BOD to design the operating conditions. As you can see here, what we did, we first done the analysis of every machine. Then we come across with the analysis of the mixed effluent. It says that COD is ranging from 500 to 1540. And there's a lot of variation in BOD and COD because of the process variation. So with these variation, it is hard to operate a plant. So first what we did some toxic study. We take the water and we did a pilot study at our lab, and we found that we can remove the 90%, 95% of the COD of the Al Rahim textile industry waste. So it has no any toxic effect. And also we analyze the bacterial population growing inside the wastewater of aeration basin, where we are generating these microbes to treat the water. And some of the strategies which we had hard troubles, because most of the textile processing industry, they generate a hot water. So for that, we need a cooling tower, because biological activity cannot grow or biological cannot sustain after 40 degrees centigrade, more than 40 degrees centigrade. And also we had some issues with volatile fatty acids at the clarifiers. So we need to think about these volatile fatty acids while we are designing our plant, because they can choke the membranes. And as you can see, what we have done here, different scenarios of operating the treatment plant depending on the different conditions. Means if you have a change in BOD and COD, if you have a change in temperature, what you need to do and what you need to adopt with your treatment plant. So we developed these 4 scenarios. You can have technical details in my report. And as you can see, finally what we did, we were able to achieve the reuse of 65% or 60% of RO treated water in Al Rahim textile industry. Now it's even functional. Now they have the recovery of 65%. So the key consideration for managing RO operation, we need ultrafiltration before to increase the life of RO. And we can avoid the reject of first stage membrane to process it further. Because when you do intensive rejection treatment, then you are increasing the cost of the RO. And also we need to perform some of the other adoption like caustic recovery, because caustic recovery can avoid the alkali loading. And with this alkali loading avoiding, we can improve the RO operation and we can reduce the TDS loading to membrane. So we had a lot of achievement from these projects. As I mentioned earlier, we saved around 2 lakhs gallons of water with these practices, and we can have the developed operating conditions for RO and water treatment plant. And we also analyze some of the wastewater compositions separately and of the combined effluent. So we had at our center, we have these facilities which we applied in the project. So if someone is interested to collaborate, we can have these equipment here and I can support, we can have a joint research. So thanks for your listening and thanks for your attention. If you have any question, you can refer me now or later.
Thank you, Dr. Singhi sir. Actually, we have shortage of time, but 2 to 3 questions some audience have asked. The first one is, what will be the cost per liter for water treatment if anybody wants to adopt your method?
Yeah, currently we have a cost of around 65 rupees per RO membrane cubic meter treatment. With the when you adopt these secondary treatment and RO treatment. And normally RO operation is around 30 rupees or 35 rupees per cubic meter when we are treating a salon or groundwater. So the cost is doubled, but the sustainability of the sector is very important, because if you tell the people that you are recovering this amount of water, it will be a value addition of your sustainability of that industry. So it's almost double what we treat the normal saline water and we treat the textile wastewater.
Okay, thank you. And second one is RO membranes units. Normally, when we want to recycle it, it's impossible. So I think it's another big issue which we should
focus.
How
you are right. So You are right. So as I explained earlier, so ultrafiltration is very important. Okay, and it depends on you. If you are treating a wastewater effluent, so you should avoid to treat the reject coming from each stage, because when you perform a double stage RO process, then you are fouling your membrane more. So this is a trade-off. This trade-off is between, for my experience with textile industry, you cannot go beyond 70 to 75% of water recycling. If you go beyond 80%, then you have a more intensive operation of RO. You fouled more your membrane. You have to recycle it more. So it's better to have a 65 or 70% recovery at the 6 to 8 hours backwashing and recycling, and with also supported ultrafiltration system.
Okay,
And
third and last one, if you know this, that is there any special incentive for the industry by the government of US or government of Pakistan, which they are giving to install the filtration plants?
Yeah, in Karachi, they have the one combined effluent treatment unit, which will be subsidized by the government. So in Karachi, what they are planning, they are offering around like 20, 30-acre land to some of the industries, where the combined effluent from 15 to 20 industries will be coming. So the operation can be managed by the industries, and government could subsidize the land or other infrastructure support. So these activities are already going on with the Karachi site area and Landi industrial area and Korangi industrial area. So Punjab government also can support their industrial sector with these approaches.
Yeah, you are right. Dr. Tanveer Ahmed, thank you very much for this informative speech. Thank you very much.
So, okay, thank you.
Our next speaker is Mr. Ben Faj Abir. Mr. Ben, can you listen me?
Yes, I'm here.
Okay. Mr. Ben Faj Abir is PhD scholar at University of Monastir, Tanzania. He will talk on the effect of ozone treatment in the bagging behavior of denim garments. It's interesting topic, and I hope Mr. Ben Faj will highlight some key issues in this field. And as this is latest technology, ozone treatment technology, so it's now I hand over to you.
Okay, thanks for you. Hello everyone. Firstly, I want to present myself, Mrs. Benfraj Abir, a PhD student in the National School of Engineering of Monastir. I'm so happy to be with you today, and I want to thank the jury members for agreeing to evaluate my study effect of ozone treatment in the bagging behavior of denim garments. Firstly, to better clarify my work, I will follow this plan. I will start with an introduction, then we go on to present the materials and method used. Next, we will study the results and discussion, and we will end with a conclusion. For the introduction, we will start by defining the bagging phenomenon. We all know that our day presents many action and movement. For example, we have to walk, sitting in different positions, pushing, relaxing, and other. So all of these options can cause deformation to the pants and create a pocket shape. This is the bagging phenomenon. Therefore, bagging is a multi-direction deformation of fabric that persists and gives an elastic appearance. So denim fabric was discovered as a work garment which is uncomfortable to wear due to its weaving and dyeing effects. Then, thanks to washing treatments such as stone washing, ozone washing, and bleaching, it was being softer, more flexible, fashionable, and more comfortable. But this treatment presents a kind of pollution in the textile industry. So, new washing technologies such as ozone treatment, laser, and other appeared. So, what is ozone treatment? Ozone is a three-atomic molecule consisting of 3 oxygen atoms. It exists as a gas that is present in our atmosphere, and it's formed naturally by photochemical reaction with solar UV radiation. It can be generated artificially by several ways. It's a very strong oxidant, and for this reason, it's used for washing denim. In fact, this fades denim fades dyed textile materials by the rupture of the chromophore in dyes of synthetic or natural fiber. So the aim of this work is to know if this treatment presents an effect in the bagging behavior of denim garment. Now, let's move to present the used materials and method. In this study, ozone treatment is applied on 6 denim fabric that have the same weave and different characteristics that is present in this table. These studied samples were cut and sewed as tubes. Then they were decided to remove the agent of sizing. Finally, they were treated with ozone wash at different conditions. To know the effect of this treatment on the bagging behavior, we changed the sample from 1 to 6. The concentration of ozone from 10, 55, and 100, the water content from 30, 45, and 60, and the time of treatment for 5, 80, and 30 minutes. Thanks to the mini tape and with a Taguchi design of 4 factors and different levels, we carried out 80 experience. Then, to evaluate the effect of this treatment on the bagging behavior, we manufacture an apparatus and integrated it to the dynamometer. This apparatus consists of 2 joy, lower and upper. The lower joy consists of 2 square metal plates which have a hole in the middle. The sample will be placed between these 2 plates, which will be compressed on far side with clamps. The upper jaw consists of a removable hemisphere with a diameter of 5 cm. During bagging test, this hemisphere applied a load on the sample up to a certain distance with different speed. Next, the residual bagging height was measured with a needle that welded to the upper jaw after a reduction time equal to 30 minutes. And then the bagging recovery percentage was calculated according to this equation. Now let's move to discuss the results. And thanks to Minitab software, the obtained results for the 80 experiments of the used Taguchi design were analyzed. The figure illustrates the main effective load for the bagging recovery percentage as a function of the investigated input parameters. Results show that the simplest input parameter have the ozone and the ozone concentration affect widely the bagging recovery percentage. The other input show insignificant variation, so they have no effect on the bagging phenomenon. To validate these results, a study of the analysis of mean was carried out. ANOVA results represent that simple and ozone concentration parameters have significant effect on the bagging recovery percentage based on the p-value test. P-value equal to 0.00 less than 0.05 for simplest and 0.080 for ozone concentration. However, time and water content parameters do not significantly affect the bagging recovery percentage p-value upper to 0.05. Regarding the factor simplest, which is the most important input parameter, the evaluation of bagging recovery percentage can be divided in 2 parts. Firstly, from 1 to 2 and from 5 to 6, it recorded a decrease in bagging recovery percentage. Secondly, between 2 to 5, the bagging recovery percentage recorded an increase. This bagging property depends enormously on the effect of simplest composition. In fact, ozone affected more cellulosic fiber than synthetic fibers, and this can be explained by the crystallinity of this fiber, which prevent their mechanical property from being affected by oxidation and from decomposing. Hence, we can conclude that the increase of cotton fibers percentage in fabric composition will decrease the bagging recovery percentage significantly. Nevertheless, the increase of ozone concentration decreases the bagging recovery percentage. When the concentration of ozone increases, the cotton fiber became more surrounded by ozone, which accentuates the hydrolysis of the glycosidic bands by this gas. This hydrolysis damages the fiber, hence degrades the mechanical property and dropped the bagging recovery percentage. Finally, to summarize, this study was revealed that the ozone concentration affected the property of bagging, and the increase of this percentage decreases the ability to recover the bagging deformation. Moreover, the increase of cotton fibers percentage in a fabric composition will decrease the bagging recovery percentage significantly, and the presence of synthetic fibers can help and raise the bagging recovery. And thank you for your attention.
Thank you, Miss Benfudge. Thank you for the nice talk. There are some short questions for you. First question is, what is the importance of bagging behavior in the denim? If you see the latest fashion industry, is it compatible with the latest fashion technology? This bagging behavior, do you think?
Bagging phenomenon is a problem for clothing. When you wear the pants, for example, and you practice your act, finally you will look the form of pocket in the at the kin of so it's a problem and an aesthetical it's an aesthetical.
Okay, thank you. And second one is, in your opinion, what would be the impact of this ozone concentration on the environment? If you will increase the ozone concentration, I think there will be effect on the environment.
When you finish your treatment, this percentage of ozone will be dewatered at high temperature, then that will be recovered to oxygen, and then will be degaged in the atmosphere.
Okay, and third question, one listener has asked that in all the ozone treatment machines, they have some limitation. They can't convert all the ozone into the oxygen. There is some limitation. Some machines, they are converting 99%. Some machines, they are converting 95%. And what about the remaining ozone after the treatment?
For the machine, it's they protect the ozone by corona discharge, and then after finishing treatment, they will transform it by a high temperature and degage oxygen molecule.
Okay, thank you. Thank you, Miss Benfudge. It was nice talk and very good study especially for the denim industry. Thank you.
Thank you.
Our next speaker is Miss Dr. Rim. Dr. Rim, could you hear me?
Yes, I am here.
Okay, thank you.
I will share my presentation.
Okay, Dr. Rim is currently working in Laboratory of Textile Engineering, University of Monastir, Tunisia. She will talk on the optimization of wet baby wipes, manufacturing conditions, and performance assessment. Now I hand it over to you, Miss.
Did you see my presentation, please?
Yeah.
Yes. Thank you very much. It's a great pleasure to be with you today. I am Dr. Rim Shria, a member of Laboratory of Textile Engineering, University of Monastir, Tunisia. I will present work about optimization of wet baby wipes, manufacturing condition, and performance assessment. This work is done in collaboration with Professor Boubacar Jawashi, and it is carried out as a part of baby wipes development within the company Sensia Lab in Tunisia. So I will begin my presentation to introduce baby wipes and to expose some industrial manufacturing complexity, of which some will be resolved in this work. Many points will be discussed, mainly the optimization of lotion mixing condition, the optimization of wipe wet pickup, and the last one is optimization of lotion compounds percentage. And I will conclude and give some perspective to this work. With the improvement of people's living standard, request for disposable most wipes in daily life, especially for personal care, is growing rapidly. If you want here to define wet wipes, there is small nonwoven substrate about 50 gram per square meter, moistened with lotion, folded and wrapped for convenience. Baby wipes account for about 32% of sales in the personal care wipes category. Disposable baby wet wipes consist of three main compounds. The first one is the nonwoven fabric, generally spunlace, made of natural, synthetic, or a combination. The second one is the lotion or the formula helping cleaning. And finally, the package, which will be not discussed in this work. The liquid lotion is a water-based emulsion, which typically contains multiple functional ingredients, such as large amount of purified water, surfactant, preservative, solubilizer, perfumes, emollients, vitamins, and antibacterial agents. Baby wet wipes in particular, there are strict criteria set forth in internationally accepted guidelines, such as wiping efficiency, a pH balanced because a birth baby skin pH is neutral. Within a few days of life, the acid mantle forms and the skin has a significant drop to slightly acid values around 5.5. And also, the wipes should be hypoallergenic. They must not contain no harmful chemical, had a precise and moderate moisture content, to be soft and stretchable, and also flushable. Let's see now the wet wipe production line is near ZFV. Available in Sensia Lab company and the manufacturing process. In fact, large diameter rolls of dry wipes are inmolded, vertically cut, folded, moved over rolls with nozzle through which the liquid lotion flows into the substrate at low rates. Then the wipe is kissed to ensure precise moisture content, cut it, then stick it. The package is finely packed. The lid is placed for a better sealing. Water treatment installation for water demineralization and steriling using ozone and UV, and a chemical mixer are also needed for wipe production. Each compound used in baby wipes passes a series of quality check points prior, during, and after the manufacturing process. Water quality is first controlled in terms of hardness, chlorine level, microbiologic agents. The non-woven fabric is selected function to multiple criteria like composition, tensile, and tear strength, and especially for absorption capacity. The lotion formula must satisfy specific microbiology criteria and other physical property like pH, color, and odor. And the final wet wipes are tested in terms of pH, weight and size, liquid retention, whipping efficiency, and the stability for 6 months. Development chemists evaluate the product to ensure that it's shelf stable and will not undergo any undesirable chemical reactions. Frequent are manufacturing complexity in the development step, and I can see it and say it here, the water quality, the non-woven behavior face to different converting process, different folding configuration, vertical and horizontal stack orientation, and also variable and various packaging format. We will be interested in this work particularly for the lotion formula and for the weight pickup factors which may affect the whipping efficiency of the developed whips. For that purpose, two types of spunlace labeled 1 and 2 were chosen for the present study. These two substrates share a similar fiber blend, 50% of viscose and 50% of polyester. The first one is more dense and thicker, offering more interfiber entanglement, less permeable, and had a lower absorption capacity. Both fabrics have a pH about 5. Scanning electron microscopy image show difference in surface aspect of the polyester and viscose. We note also that the second one is clearly more porous, and here the presence of large number of pores provides more capillary canals to transport liquid, as it is clear here. A slight difference is also noticed in their tensile strength. The behavior of the two fabric will probably not be the same on the production line and also for machine adjustments. An approximative recipe of the lotion proposed by the company's research and development laboratory is presented here and contains 5 main compounds. The first compound presents 81% of purified water. The second one contains 70% of mixed surfactant mixed with vitamins, anti-inflammatory agent, and other ones. The third compound is a mixture of preservative that keeps the whip hygienic and sterile by the time. The next one is a solubilizer, and finally 0.2% of perfume. This recipe had initially satisfied microbiologic requirement and was proposed for manufacturing. In order to obtain an homogeneous lotion, it was necessary to choose optimal mixing condition using a laboratory popular axial mixer. Mixing speed was ranged from 60 rotation per minute to 255 rotation per minute. The speeds coincide with the limits of the industrial mixer. And the mixing time was ranged from 10 to 30 minutes, and the addition order of the compounds was left fixed. The droplet size and the morphology of the multiple emission were investigated by optical microscopy using glycadian microscopy. I just here present some extremum results which show that mixing speed reduces all the droplet size across water. That homogeneous emulsion oil in water is obtained using 110 rotation per minute for 20 minutes. Besides, at higher speeds, the formability of the lotion appears as an undesirable phenomena, which will undoubtedly complicate the lotion application on the wipe in the production line. Weaving efficiency is also one of the important criteria of wapes quality. There are many test methods to determine weaving cloth property and efficiency, such image analysis, Gardner apparatus, the colorimetric measurement, the contact angle measurement. The method used in our study is the gravimetric method, during which a mass of melted chocolate is deposited on the hand, then whipped by the wet wipe. It's well known that whipping efficiency is a function of whipping speed, whipping pressure, and viscosity of the contaminant. That's why we try to operate in similar conditions. The repeatability and reproducibility of the results obtained is satisfacient using 10 samples. Precise and moderate wet pickup must be then fixed to guarantee whipping efficiency. The wet pickup was first fixed using laboratory skeezer rolls. We can decide here that the moisture content about 45%, which is 3 grams of liquid per gram of fabric, fabrics is sufficient to obtain an optimal whipping efficiency about 80% for both spun laces. However, a higher wet pickup make wipe drip and the lotion sinks to the bottom of the package. Besides, the high water content of wet wipes makes them a breeding ground for mold and bacteria. On the other hand, the decrease in wipe lotion content less than 50% show a slightly clean skin, so dry wipes are not likely to collect surface salts and readily as wet wipes, and how long wipes remain moist could affect collection efficiency. As I mentioned above, lotion mixing generates a bubbly liquid, but the problem is getting worse when lotion is in contact with spun lace, especially in padding rolls and at high machine speeds. It is determined from this figure that that compound made of solubilizer, surfactant, and seems to be the probable cause of foam generation, as it contains tensioactive agents. Anti-foam agent can't be added to the recipe, so we decide to optimize a lotion formula in order to reduce the foam power of the solution in complement of whipping efficiency. For foam power measurement, the method includes pouring the lotion from a height of 90 centimeters into a graduated beaker already filled with 50 milliliters of the same lotion. We measured immediately the height of the foam formed as an indication of the foaming power of the solution. So here a factorial experimental design was used to optimize the recipe, where the first compound based on surfactant was ranged from 10 to 17 and the solubilizer from 0.08 to 0.12, and preservative and perfumes are let fixed. Using Minitab statistical software, the main effects flow are presented here. And it should be noted that the steeper the slope of the line is, the greater the magnitude of the main effects. As it can be noticed that whipping efficiency and lotion foam power are highly influenced by surfactant percentages, as you can here see in this figure, but a less degree of solubilizer, which acts as emulsifier and surfactant in the lotion formula and reducing the surface tension of maybe because it's low concentration in the lotion. The next figure present interaction plots where the greater departure of the lines from the parallel state, the higher the degree of interaction and more the degree is rising. The interaction plot shows here that the relation between the whipping efficiency and the solution foam power and the surfactant percentage depend on solubilizer content, especially at a high percentage. Regression model and ANOVA analysis was used to modelize the response. For this result, the adjusted coefficient of determination of the two models was found to be moderately high at an R square more than 80%, and the p-value was statistically significant at 95 level percent. From this, the value of the intercept and the regression coefficient, the prediction models for the whipping efficiency and foam power was rewriting as a function of solubilizer and surfactants 1 percentage, using desirability function to minimize the lotion foam power and to maximize the whipping efficiency of the whip. In the formula, the optimum results were found here, and the surfactant percentage was 15.7% and 0.08 for the surfactant for the solubilizer, and the other ones are maintained fixed. As a conclusion, a cooperative work is carefully planned in collaboration with the Science Laboratory, Laboratory and Development Laboratory to solve some wet wipes manufacturing complexity. Baby wet wipes adhere to strict criteria set and must pass a series of quality checkpoints during manufacturing. Chemical mixing conditions are proposed to guarantee homogeneous lotion solution, and results are confirmed in industrial scale. Squeezing rules should be adjusted to allow wet pickup about 245%, so 3 grams per 2 grams lotion per 1 gram of fabric. And experimental errors cannot be avoided in case of gravimetric methods, which is the general testing method used for determining the whipping efficiency. An optimal recipe was proposed to reduce foam generation during manufacturing with compliant of whipping efficiency. Results are validated and used industrially. And for further works, we have a continual improvement of wet wipes products with Sensia Lab company, and we thought about lotion dispersion and stability on the substrate test, and we can also test other whipping efficiency methods. Thank you very much for your attention.
Thank you, Ms. Rim. It was nice presentation about the wet baby wipes. There are some multiple questions for you. Some of the baby wipes, wet baby wipes, react with the baby skin. So what are the possible reasons of this reaction?
About which product, which chemical?
Some of the baby wipes, they react with the skin of the babies. And
W, which is the W?
Some of the baby wipes, they react with the skin of baby skin, with the baby skin. So what are the possible reasons?
Yes, because the skin of a baby has pH about the skin of the baby is in first days it is neutral, and as I talk it is acid in the next days, and and can irritate the skin of the babies. It's
Okay.
about the pH.
And what you have prepared very good wet wipes. So in your opinion, what is the cost comparison with your baby wipes and the market available baby wipes?
About the cost?
Yeah, cost.
Yes, it's about for dinners in Tunisia.
Your product is cheaper than the market products?
No, no, it's a medium.
Okay. And third and last question is,
yes.
You know, most of the baby wipes, they contain, they are composed of polyester fibers, and polyester is not a environment friendly fiber.
Yes.
In your opinion, should we use these baby wipes at the cost of environment?
Yes, it is a blend of polyester and viscose, and polyester here is added to give some strength to our products, and viscose is used for a fiber which is preferred compound of fiber plants, as it provides desirable wettability for most cleaning lotion. Then when they are used as compound of the non-woven fabric, because the relatively high surface energy of viscose rayon.
Okay, thank you, Ms. Rim. It was nice talk about the baby wet wipes. Thank you for your speech.
Thank you.
Our next speaker is Mr. Muhammad Riazuddin Rappel.
Yes, I am here.
Okay, thank you. Mr. Riazuddin is researcher at Department of Production Engineering, Faculty of Mechanical Engineering and Design, Kaunas University of Technology, Lithuania. He will talk on the silver-based electroconductive heating fabrics in orthopedic compression sports. It's nice topic of the presentation, and I hope all the listeners will get something from your speech. Now I hand over to you, Mr. Muhammad.
Yes, can you see my screen?
Yeah.
Everything okay?
Yeah, go on.
Okay, good afternoon, everybody. Thank you. It's nice to hear. It's good for me to share my work in this online event organized by National Textile University. This is Riazuddin Ripon. I'm working on silver coated polyamide based electroconductive heating fabrics in orthopedic compression support. I'm working in Kaunas University of Technology in Lithuania. Today's my works outlined is in introduction, materials method, and resultant discussion and conclusion. Introduction. Electrically conductive textile is a part of smart textile that includes conductive fibers, yarn, fabrics, and final product made from them. Conductive fabrics have obtained increased attention for many purposes. An important application area of conductive textiles is for heating purpose. Two ways to produce heated textile. One is produce a textile fabric and then integrate the electronic components. And another is produce electroconductive yarn with electronic feature and then produce textile of yarn. And it is known that heat therapy helps to relax stiff joints and reduce pain. Due to age-related loss of active muscle mass, the temperature of the skin and deep muscle decreases. Decrease in the body temperature can profoundly change the motor function and performance. However, there is a lack of investigation in the field of heated compression support used for the orthopedic therapy published in the literature. The temperature required for the joint therapy is around 40 to 45 degrees Celsius. It means that this temperature has to be reached and kept constant for the particular time. Moreover, the heating of the orthopedic support has to be solved without additional rigid element to avoid the changes in the support compression. You can see in the figure, there are used at least 2 rigid elements in the construction of the orthopedic compression support that have significant influence on the compression properties of the support. Therefore, the heating element have to be flexible and directly integrated into the knitted structure. That means the knitted structure has to work as a heating element. To reach it, electroconductive yarn is knitted together with the elastomeric ground yarn. Therefore, the aim of this work was to develop a compression knitted structure with integrated electroconductive silver-coated polyamide yarn and to investigate their heat generation characteristics. This is the materials and method. The silver-coated yarn of 2 types of linear densities is 66 tex and 235 tex linear density are used as a conductive yarn. These 2 variants of linear density were chosen as possible marginal values suitable for plated structure in combination with the selected yarn for the ordinary elastomeric structure used in the orthopedic support. The specimens were knitted on a flat double bed needle knitting machines in combined half Milano rib structure with elastomeric inlay yarn inserted into the every course of the knitted structure. The half Milano rib structure was chosen in order to situate an electroconductive yarn on one surface. Therefore, the conductive yarn were used only in the single jersey course of the pattern. That is the knitting structure and the amount of conductive yarn in the knitting pattern. Now, results and discussion. The DC voltage was applied on the electroconductive surface and required time allowed to heat up. The surface temperature of the fabric was measured at the fixed voltage level after each 10 seconds during the first minute of the observation and after each 20 seconds starting from the first minute till the end of the experiment. That means I have observed the temperature of characteristics until the 10 minutes. You can see the result from the presented result. It can be seen that temperature rises initially quickly, but after the approximate 90 seconds, the temperature rises becomes very slow. And finally, the heating process becomes stable. The behavior of the temperature is very reasonable, as with the increase of the temperature, the heat loss by the radiation and air convection is increasing. And finally, the balance between the heat generation by current and heat loss is achieved. There is we made the 6 different knitted specimen depending on the electroconductive yarn amount and distribution in the knitted structure by 2 variants of electroconductive yarn linear density. And finally, the compared the heat generation. That is the first one and second one and third and fourth one. The same behavior, the same character was observed for the all specimen developed for the orthopedic support. But for the low linear density yarn, the applied voltage was high, but for the higher linear density yarn, its applied voltage was lower. That is the thermal images and the influence of the knitting pattern. That is the amount of conductive yarn used in the knitting pattern, as well as the distribution in the pattern is clearly demonstrated in this figure, where yellow color indicate the highest temperature. It's 40 to 45 degrees Celsius, while the blue color according to the lowest temperature. And last is conclusion. The proposed combined half Milano rib structure for compressive heated orthopedic support has an advantages as the electroconductive yarn used as in the ground yarn in single jersey course and is plated by the polyamide 66 yarn. it was expected the highest temperature was generated on the surface of the specimen with higher insertion of the conductive yarn in the knitting pattern in this research. The single jersey course of this half Milan structure. When the conductive yarn is laid in the higher distance, the temperature unevenness appear in the surface of the knit, and the unevenness is higher for the fabrics with lower linear density conductive yarn. All the presented electroconductive knitted structure can be used for heated orthopedic compression support. However, the higher linear density of the conductive yarn requires an energy source of lower voltage to reach the required 40 degrees Celsius temperature. For electroconductive with the higher linear density yarn, 1.5 voltage was used, and for the lower linear density is for the 2.5 voltage for the first variant and the 3 voltage for the rest of the variants. The temperature of the heated specimen in all cases rise during the first minute very quickly, but later on this rise becomes very slow for all the voltage applied until it reaches the constant below. The relatively stable 40 degrees Celsius heating temperature was reached in 30 to 60 minutes, depending on the specimen and the knitting pattern. These are the references for the text. And I want to thank the Professor Daiba Mikuchonane, Faculty of Mechanical Engineering and Design of Kaunas University of Technology. And thank you very much, all of
Thank you, Dr.
for hearing me and for attention. That's all.
Thank you for your speech. There are some questions for you. First and important question is for the flow of blood, specifically in the old age patients, specific temperature is very important. And
yes,
in compression sport, control of temperature is impossible. So in your study, how will you manage this control of temperature?
Actually, in this, the developed specimen developed samples in my study is the stable temperature, and that is 40 or to 45 degrees Celsius, and this is stable within 45 to 60 seconds. So it's easy to control within the time or in a specific voltage applied.
There is some sensor, it means.
Yes.
Okay, good. And the second one is, how about the strength and abrasion resistance of this compression sport? I think
yes,
using polyamide, then its strength and the abrasion resistance will be outstanding. Should be.
Yes, it's very nice because of the lack of times. I cannot put my results of this strength because you know that for the compression garments or compression support is very important for the stretching. That is one thing. I cannot put the all the results here, but strength is okay because polyamide does not decrease the strength up to the 45 degree Celsius is not matter.
Very good. Thank you, Mr. Muhammad Riazuddin Rapan from Kaunas University of Technology. It was nice talk on the orthopedic compression sport. Very nice. Thank you.
Thank you all of you for giving the opportunity to talk about my works.
Thank you. Our next speaker is Miss Imani Ghazal.
Hello.
Okay. Miss Imani Ghazal, she received her doctorate degree in 2019 and her textile engineering diploma in 2014 from the National Engineering School of Monastery. She is member of the Textile Engineering Laboratory, Tunisia. In 2018, she obtained the Raintex Award first prize and the third prize at a national scale in 180 seconds competition. In 2021, she became a member of the Tunisian Association of Textile Researchers Steering Committee. Very good researcher. And she is going to talk on the scrutinizing the air permeability of a coated cotton polyester blended fabric designed for producing medical protective gowns. Yes, I hand it over to you, Ms. Amani.
Okay, thanks, Professor. Assalamu alaikum. Good afternoon, good morning, in some other places in the world. I hope that you all are doing well and to see you in good health by the end of this pandemic. First of all, I would like to thank the organizing committee and the scientific committee for giving me the opportunity to be present in this conference. Thank you so much. And professors and dear professors, dear colleagues, as you know, despite the discovery of a vaccine for the coronavirus, it is still not produced with sufficient quantities. The quantities are still limited. Added to that, the pandemic is new, so there is not a lot that is known at that point. But what is well known is even after a couple of months of hospitalization, COVID-19 patients are still suffering from many diseases like many medical health problems such as breathing issues, headaches, fatigue, etc. So the best alternative is trying to avoid all these virus by using protective garments. And many researchers were working in this field. And when it comes to textile area, many protective garments such as protective gowns, barrier masks were produced. So the presentation that I'm going to present today entitled Scrutinizing the Air Permeability of a Coated Cotton Polyester Blended Fabric designed for producing medical protective gowns. But first of all, let me introduce myself and my research team members. I'm Dr. Iman Ghazel from the Textile Engineering Laboratory. I had my doctoral degree in 2019 and my engineer degree in 2014 from the University of Monastir, Tunisia. My field of work is waterproof breathable fabrics. And this work was done with Professor Fawzi Sakli, full professor in textile engineering in the Haya Institute of Technological Studies in Qasr Tunisia, and Dr. Boubacar Jawashi, associate professor in textile engineering in the National School of Engineering of Monastir. So before getting started, let me present the agenda of my presentation. I'll begin with a small introduction, move then to a review on protective gowns, why using protective gowns, the different type of these garments, and I'll present the evaluating methods of protective gowns. Then I'll move to the experimental part in which I'll present the coating treatment that we have used to produce gowns. And after that, we will focus on the analysis of the air permeability of the coated fabrics, and I'll sum up with a conclusion. So, as you know, the year 2020 was more than a pandemic year. Actually, it has had a devastating effect on all the world by around 2,474,000 deaths that were recorded by the World Health Organization from the beginning of the coronavirus disease until date. And this disease has not only caused deaths, it has also affected the economic all over the globe. And many countries has experienced economic crises. And if we take as an example the Tunisian country, the Tunisian, my country, the world's economic situation has affected it, and we have noticed a huge decrease in production, especially in textile fields. So the textile Tunisian manufacturers tried to find solutions and to produce personal protective equipments which are known with a good added value compared with low prices. So what they have done is trying to produce protective gowns and barrier masks in order to avoid the occurrence. And the objective of our work were the development of a coated fabric for producing protective gowns. And in this presentation, I'll focus on analyzing its air permeability. So let's now move to a review on protective gowns. So the first question is why using this type of garments? First of all, it's to protect healthcare providers and patients from potential surrounded hazards, and also to avoid a field from the contamination by individuals. Protective gowns can be classified according to a major classification to disposable, meaning single-use gowns, and to reusable multi-use gowns. So here are some example of commercialized gowns. Here are disposable gowns and reusable gowns. So disposable gowns are made with non-woven fabrics, generally made with synthetic fibers. And for reusable gowns, they are made with tightly woven plain weave fabrics with cotton, for example, or polyester, or sometimes with blends of cotton and polyester fibers. Both types of these presented gowns can be laminated or not with a polymeric film. So to evaluate the performances of these gowns, we can measure the moisture vapor permeability and the air permeability. Both these characteristics are generally related to the comfort property. We can also do the spray impact penetration test or the resistance to water penetration under hydrostatic pressure. Both these characteristics are related to the hydrophobic property of our gown. And to evaluate the mechanical property, we can do the grab tensile test, the Emmons-Zorn shear test, members, or even we can test the stiffness of our fabric, which is also related to the comfort of the wear. So in this research, I'll focus on evaluating the air permeability of our coated fabric. So let's now move to the experimental part, where we have developed a coated fabric by coating a plain weave textile. Here are presented a microscope image of our fabric with some characteristics, some of its characteristics. It's a plain weave, it's a blend of cotton and polyester, and the multi-filaments in this fabric are around 300 micrometer. So as I said previously, we attempt to coat this fabric with a coating paste, which comprising fluorocarbon resin and acrylic paste. So all samples were coated by using the screen coating process, dried for 5 minutes at 100 degrees Celsius and reticulated at 116 degrees Celsius. And to evaluate the performances of our fabric in terms of air permeability, we have varied the acrylic paste quantity, the carbon resin quantity, and the reticulations time by using the Minitab software and by using the box Binken experimental design. Each level will vary according to each factor was varied according to 3 levels. And by the aim of this experimental plan, we generated 15 experimental sets, and each set was repeated 3 times. So let's now move to evaluating the air permeability of our substrate. So we used the Textile FX303, the Textile FX apparatus, and we did our measurement by using the ISO 9237 standards, and we evaluated our plain weave fabric before undergoing the coating treatment, and its air permeability was equal to 396 and 403 respectively for fabric inner face and outer face. So after treating our samples, we used the Minitab software to generate the main effects plot. And as you can see, we have almost the same effect for the fabric inner face and fabric outer face. Here are presented the 3 parameters that we have varied. And we will just focus on one figure. So as you can see, the air permeability decreased significantly to pass from around 400 to 100 liter per square meter per second. And we can see that in general, woven structures are considered as hierarchical porous structures, and that the coating paste has fulfilled interfibers and interyarn spaces, which decreased the air permeability of our fabric. Let's now focus on each parameter. So here you can see that the effect of the acrylic paste is the most significant, with the p-value equal to 0.005, which is very low compared to 0.05. But however, the fluorocarbon resin has a non-significant effect. So we concluded that varying fluorocarbon resin quantity between 5 and 15% does not influence really the air permeability response. So here are presented images by using an optical microscope by Leica M15 for our woven fabric before plain weave fabric before and after the coating treatment. And as you can see, interfibers and interyarn spaces were fulfilled with the coating paste. This explains the huge decrease in air permeability after the coating treatment. Here also we can see the effect of studied parameters, but in a 3D presentation. So you can see that the acrylic paste, as I said previously, has the most significant effect, which is produced by a plotted surface that is deviated by around 45 degrees from the horizontal plane. However, for the fluorocarbon resin, the plotted surface is almost parallel to the horizontal plane. It is also important to have an idea about the interaction between different parameters. So the non-parallel lines here indicates that there are always interactions between studied parameters, meaning that varying one parameters will affect other parameters and affect the whole response. And here, for example, for reticulation time equal to 2 minutes, and a fluorocarbon resin quantity equal to 15%. Here we can have the highest air permeability value. However, when we change the reticulation time to 6 minutes, the highest air permeability is obtained with 10% of fluorocarbon resin. So by using the same software and the box banking experimental design, we were able to generate response models for our air permeability for the fabric inner face and the fabric outer face. And A corresponds to the fluorocarbon resin quantity, B is acrylic paste quantity, and C is reticulation time. And both these models enable us to predict the air permeability for our fabric with a good accuracy. So to conclude, the aim of this research was to evaluate the air permeability of a coated fabric designed for producing medical gowns. The applied coat was comprised fluorocarbon resin quantity and acrylic paste quantity. Both these products were mixed together and applied to our fabric by using the screen coating process. The box banking experimental design was used to evaluate the effect of each parameter on our response, which is air permeability. And we have noticed that the acrylic paste has the most significant effect on the air permeability response. Two models were set to predict with a good accuracy the air permeability of both fabric sides in the experimental design of interest. This brings us to the end of my presentation. Thank you so much for your interest. I would also like to thank again the organizing committee and the scientific committee. Thank you very much for your efforts. If you have any questions, please do not hesitate to ask.
Thank you, Ms. Emmanuel. It was nice to eat, but there are also some questions.
Okay.
The first question is there any effect of resin and paste on the skin and its safety?
Actually, no, because what I have used here is an acrylic paste and fluorocarbon resin, and I have already used this mixture for producing a waterproof breathable fabric. But in the other research that I have conducted during my PhD research, we applied the code to a knitted structure. So here, acrylic paste was supplied by a chemical supplier who has give us the the security data sheet, and all the used products are safe. No problem with the skin.
Okay, and the second one is the previous literature shows that the acrylic resin is not good for the environment. And
for the environment,
what would you say about this?
Okay. So what I know that fluorocarbon resin is not good for the environment and not the acrylic paste. But even though, as I said, when choosing our products, we try to have a global how to say, to see in global that they respect the rich normalization. So we don't really face this problem of non-environmental products. No, it's okay with the products.
And the third and last question for you is, have you checked any antimicrobial or antiviral activity of these gums?
Really not yet, because we just began with this research. So we aim to do that. We aim to do that in the future, inshallah.
Okay. Thank you, Dr. Imani. It was
Thank
nice.
you, Professor. Thank you.
About the air permeability of coated cotton polyester blended fabric. It was nice. Thank you. Thank you.
Thank you. Thank you.
Now, all the present speakers have been completed their speech, and the next session is our short video session, in which multiple recorded videos of different researchers we will run here. Now we will start with the short video presentation session. Our first presenter is Dr. Waqas Iqbal. He is assistant professor in the Department of Textile Engineering in National Textile University, Faisalabad. He did his PhD from Hanyang University, South Korea in Industrial Engineering and Management. The topic of his presentation is challenges of processing pre-consumer textile waste. Okay.
Bismillahirrahmanirrahim. I'm Dr. Waqas Iqbal and I'm presenting on challenges of processing post-consumer textile waste. Post-consumer textile waste is the waste of clothes that have expired their useful life. Such waste still has some value that can be reused, donation for example, made into new products from pieces of fabric or recycled into fibers. Key issues in the recycling of post-consumer textile waste include collection of used garments, their segregation and removal of accessories. Collection of used garments is an uncertain process due to consumer habits and incentive methods. The rate of return is not deterministic, that disturbs the smooth supply of material to the production. Segregation of collected textile waste is carried out based on their type, color and composition that further affects the recycling process. Removal of accessories is an additional process involved in recycling post-consumer textile waste that is necessary to separate fibers and avoid machine damages. The process of recycling includes classification of textile waste based on color and composition, removal of accessories, shredding of the fabric or garments into coarser stripes, fiber to fiber opening, and finally spinning the fibers into yarn. This yarn can further be used to make fabrics and recycled garments. The recycled yarn is cheaper and gives higher productivity, but delivers poor quality and only coarser counts can be prepared. Most importantly, recycled yarn is sustainable. which is going to be a trend in the next few years. The most famous brands such as H&M, Adidas, Nike, and others are making their production lines sustainable. That is the need of future. Thank you.
Thank you. Thank you. Our next speaker is Dr. Ali Afzal. He is assistant professor in the Department of Textile Engineering in National Textile University, Faisalabad. He did his PhD from Université de Haute Alsace, France, in mechanical engineering. The topic of his presentation is improvement in operator skill and accuracy level through quality management system in apparel industry. Over to you, Dr. Ali Afzal.
Hello everyone. My topic is improvement of the operator skills and accuracy level through quality management system in apparel industry. As we know that the quality is the basic parameter through which we define the requirements of the customer, and it addresses the product according to its end uses. So the quality is the basic thing. If we compromise on the quality, it means we are compromising on the price and obviously the customers as well. So in such regard, we are going to increase the skill and accuracy level by the implementation of quality management system in an imperial industry. The industry which was considered in this study was a local industry in Pakistan, which was producing the apparels. Regarding the quality management system, there are some basic steps which is the PP meeting, trial run, and inline report, endline report, critical report, specs report, internal audit. Objective of the study is to check the awareness of the operator towards the fault and to check the skill level of the operator towards the required quality, and afterwards to improve the skill levels of the operator. Procedure adopted for the implementation of this study is to assess the skill level of the operator and their error percentages, and afterwards, in order to reduce the number of operator errors, our training method was developed with the support of the attribute agreement analysis method with test images presented to operators for classification. By using this methodology, it was possible to check the capability of each operator and improve the operator's evaluation score. And afterwards, again, the test was done, and a comparison was made between the quality before and afterwards. According to the results obtained, it was observed that the overall error percentage before the training was 19.3, which was reduced to the overall error percentage of 10.7 after the training, which shows that there was a good reduction in the error percentage, and the operator skills have been improved after the training. According to the skill levels, the operator skill is increased from 78% up to 97% skill level. The highest skill level is reached up to 97, and 5 out of 16 operators are increased from below 80% to the autonomous level above 90%. From the above study, it is concluded that the quality has been considerably improved by the implementation of the quality management system in an apparel industry. According to the training sessions which were developed and implemented in the procedure, it was concluded. It is concluded that the training considerably improves the operator's skill level, and error percentages has been reduced considerably. According to the operator's accuracy level results, it is concluded that the fault identification of the operators has been considerably improved, and uh, uh, the quality of the apparel industry has been improved for producing quality products. Thank you very much.
Thank you, Dr. Ali. It was a nice study. Now, our next presenter is Dr. Muhammad Irfan. He is the assistant professor in Department of Textile Engineering in National Textile University, Faisalabad. He did his PhD from Politecnico di Torino University, Italy, in chemical engineering. The topic of his presentation is development of composite polymeric electrospun nanofibrous webs with antibacterial properties. So we will start his presentation.
Assalamu alaikum. I am Dr. Muhammad Irfan from Department of Textile Engineering, National Textile University, Faisalabad. I am going to discuss our study about development of composite polymeric electrospun nanofibrous webs with antibacterial properties. Antibacterial materials and surfaces are required for various applications. For example, in medical implants, antibacterial properties are required to avoid post-implant infections, which are common in hip implants, knee implants, dental implants, etc. In filtration applications, filtration media needs to have antibacterial properties in order to eliminate bacteria from filtered air or water. Similarly, textiles used in healthcare infrastructure need to have antibacterial properties to avoid transmission of infectious bacteria due to textiles. Nanofiber webs or membranes can be used in various applications such as water or air filtration. Metal nanoparticles are attractive for imparting antibacterial properties to textiles, and silver nanoparticles are most commonly used nanomaterials in commercial products and in research activities. They are attractive because they show antibacterial effect against a wide variety of microbes. However, synthesis of silver nanoparticles is not usually environmentally friendly, and their incorporation within the polymer matrix is a multi-step process. In this study, we prepared PVDF PVP silver nanoparticles composite nanofibers, where silver nanoparticles were synthesized using reducing properties of PVP without the use of any additional reducing agent. PVP act both as reducing and stabilizing agent for silver nanoparticles. Silver nanoparticles were prepared in PVP solution in the dimethyl formamide, and their synthesis was confirmed using UV visible spectroscopy. UV visible spectra of PVP solution does not show any absorption, whereas when silver nanoparticles were synthesized on addition of silver nitrate, we got an absorption peak at 398 nanometer. This indicates formation of silver nanoparticles, as it is a characteristic peak of silver nanoparticles. This picture shows the scheme of the preparation of PVDF PVP silver nanoparticle nanofiber webs. While preparing silver nanoparticles in PVP solution, PVDF solution was also prepared in dimethyl formamide. Afterwards, both of these solutions were combined and electrospun to get PVDF, PVP silver nanoparticle composite webs. During this process, electrospinning process parameters were optimized and webs containing different concentrations of silver nanoparticles were prepared. After preparation, FTIR spectra of PVDF and PVDF PVP silver nanoparticle composite webs were obtained, which indicates successful fabrication of PVDF and the composite membranes containing silver nanoparticles. Antibacterial activity of these nanofiber webs was assessed in inhibition hollow test, which is a qualitative test method for the evaluation of antibacterial activity. These results show that nanofiber webs containing silver nanoparticles formed an inhibition halo around the samples, showing their antibacterial effect against the tested microbe, which was Staphylococcus aureus. Whereas control sample that did not contain any silver nanoparticle did not show any antibacterial effect, as there was no inhibition halo formed around this sample. These nanofiber webs with antibacterial properties can be used in various applications such as water or air filters. Thank you very much for your attention.
Thank you, Dr. Mohammad Irfan. Now our next presenter is Dr. Sharjeel Abid. He is Assistant Professor in Department of Textile Engineering at NTU Faisalabad. He did his PhD in electrospinning. He will speak on sustainable dispersed dyeing process for polyester fabrics. Now we will start his presentation.
Bismillahirrahmanirrahim. My name is Sharjeel Abad and today I'm going to talk about sustainable dispersed dyeing process. So a process is sustainable if it is using less amount of natural resources or it is generating less amount of toxic waste. So it could be less energy consuming process or less water consuming process. As we know that dyeing and finishing or pre-treatment of textiles requires a lot amount of water. So when we talk about polyester, what is polyester? Polyester is a synthetic material produced from petrochemical resources. So due to its extraordinary properties, it is one of the most popular textile materials of the world. And it is being used from common household items to industrial applications. So as the applications are various, its production is high. So we can see that from 1980 to 2020, the global production of polyester fibers is 100 million metric tons per annum. So this is quite high than other fibers like cotton or wool. To give a color to polyester fibers, there is a special class of dye called synthetic dispersed dyes that are used to dye these fibers. So the process of dyeing of polyester is different than other fibers and it requires elevated amount of temperature like greater than 130 140 degrees centigrade and additional process of reduction clearing. So when we talk about what is the dyeing of polyester, here we can see that at low temperature these are the dispersed dye molecules and these are the polyester fibers, and when we raise the temperature the polyester fibers swell and the dyes can penetrate inside the fiber, and when we cool down the dyeing bath, the polyester fiber entraps the dyes molecules within their structure, and also there is some fixed and unfixed dyes on the surface of the polyester fabrics. So this is the point where we see that we have to remove these dyes so that the fastness properties are good, otherwise the fastness is not going to be okay and you have to like bear the cost. So therefore there is an additional process that is reduction clearing. So when we move towards what is reduction clearing, we can see that this is a dispersed dyeing profile. So after holding temperature at 130 to 140 degrees centigrade, we cool down the bath and then we drain the bath and we add the reduction clearing SP, that is sodium dithionate as well as some alkaline agent. So the sodium dithionate is not environmental friendly. It produces a different amount of sulfur chemicals and other chemicals as well that are toxic. Therefore, it increases the wastewater's biological and chemical oxygen demand, and it is not environmental friendly at all. So the production time is also high. Why? Because the reduction cleaning is additional process, and therefore it also requires some sort of energy and water to properly clean the fibers. So what if we don't do the liquor drainage after dyeing and we don't do the reduction cleaning with conventional way? So in this way we can reduce the amount of water being drained into the atmosphere. So what we can do, we can add our chemicals, that the sustainable ones that we are adding already here, instead of throwing the bath away, and the whole process combines. So we don't have to take the fresh water and then apply the heat and energy to get to 80 degrees centigrade and then hold there for 20 minutes. So these two processes when meted, we can have the time saving of 40 to 45 minutes. So the production is less, production is high, and no toxic chemicals are being used. So it also generates less amount of biological and chemical oxygen demand. So this is a complete sustainable process as compared to the conventional one. So when we compare the results with the conventional reduction cleared fabrics, we see that the rubbing fastness is almost same. Similarly, the dry rubbing fastness is almost same. But when we come toward the washing fastness, the conventional performed a bit better. According to grayscale, the rating is 4 to 5. On the other hand, the sustainable was around 4 rating according to grayscale. So this is not a huge gap. So this is acceptable as well. And when we talk about the shade change, delta S, the shade change according to grayscale is almost same before and after wash. So this means the results are almost comparable, but we are getting sustainable production of fibers dyed with dispersed dyes. So here we can see the sample of conventional RC, and these are the sustainable ones. Another thing that we can observe, that the sustainable process, the color depth is more as compared to the conventional one. So we are doing the investigation on this, and the results will be shared soon. So if you have any sort of question, so you can email me at my email address. Thank you very much for your time.
Thank you, Dr. Shajir Rabi. Now our next presenter is Mohammad Nadeem. He is the research assistant and MS Textile Technology student at National Textile University, Faisalabad. His research topic is comparison of protective cut-resistant gloves for better comfort properties. Now we will start his video presentation.
Bismillahirrahmanirrahim. I am Mohammad Nadeem, graduate from University of Agriculture, Faisalabad, and currently working as a researcher under the supervision of Dr. Hafsa Jamshed, Group of Protective Textile, National Textile University, Faisalabad. And I am also enrolled in MS Textile Technology in the same university, National Textile University, Faisalabad. Before starting my presentation, I would like to thank the organizer of this conference and the team who give me a chance to present my research work in the 6th International Conference on Value Addition and Innovation in Textile. Now we will start the presentation of my research work. The comparison of protective cut resistance gloves for better comfort properties. In this research work, first of all, we will see what is protection and why we need protection, and what are the equipments used for the protection purpose. From these equipment, uh, cut resistance gloves, why necessary, and what type of material we use to produce comfortable cut resistance gloves. After that we will see the results and then we will conclude. In this slide you can see there is different protective equipment like helmet, goggles, uh, gloves, and these are various equipment that are necessary for the workers to perform well work in a happy environment. So these from these equipment, cut resistance gloves, why we need and in which fields we must require cut resistance gloves. We will see in this. We can see in this slide. Uh, Here you can see cut resistance gloves are mostly used in meat cutting process, metal sheet manufacturing units, glass manufacturing units, and while using of sharp and edges tool. You can see as shown in the picture, in meat cutting process and other various fields, our hands are not much proper safe. To perform our task, we need uh, comfort, we need protective comfort characteristics to protect our hands. So we emphasize to develop the cut resistance gloves as per demand of the user and customer, as there should also some comfort characteristics so that wearer could perform his task for longer time with best environment and with the best comfort characteristics. As we know, there is a lot of comfort. There is a lot of cut resistance gloves available in the market, but there is some deficiency of comfort characteristics. To develop to develop these characteristics, we use various types of comfort fibers like mod acrylic and viscose in high performance fibers. Now we developed four types of gloves at seamless gloves knitting machine, and then check the physical properties and then comfort properties and the cut level index level 5 we keep same for all samples. We use various equipment for the testing like GSM cutter, thickness tester, air permeability tester, COP tester for the cut level index, and analyze on the basis of these testing results what is the better uh, comfort characteristics of the gloves. In this research, we kept the stitch length, physical properties like GSM and thickness uh, of the samples. We checked the physical properties like GSM and thickness that showed various results due to the fiber effects of various blend ratios, and uh, we keep the stitch length constant like 7 millimeter and cut level index 5, that is the main requirement of cut resistance, and then check the thermal resistance, air permeability and water vapor to analyze uh, and characterize the better from them. At the end, from the physical results and comfort results, we concluded that the gloves having more percentage of viscose fibers showed better air permeability, and it will be considered, and hence it will be considered good for summer wear. And the gloves has more percentage of para-aramid, uh, show better thermal resistance, and it will be better for winter wears. And so this research will be beneficial for the customer with their functional needs correct as per with respect to comfort characteristics with their functional needs, and it will be helpful for the growth of industry of textile. Thank you.
Thank you, Mohammad Nadeem. Now we will go for the last speaker of today's session, Dr. Hafiz Afan Abid. He is the Assistant Professor in Department of Textile Engineering, National Textile University, Faisalabad. He did his PhD from Technical University of Liberec, Czech Republic. He will speak on investigation of mechanical properties of cotton fabric after hot and cold mercerization. Now we will start his video presentation.
Assalamu alaikum. This is Hafiz Afan Abid from Textile Processing and the Department of Textile Engineering. The topic for my presentation is investigation of mechanical properties of cotton fabric. First of all, why this study is carried out, as cotton satin fabrics are widely used in home textile sector for industry. There are some issues in cotton textile satin fabrics, as these fabric needs to be mercerized before dyeing and printing, and for in order to get deep shades. The tear strength of the fabric tends to decrease after mercerization. It is reported that mercerization tends to affect mechanical properties less as compared to hot mercerization. And a study needs to be carried out to what extent the mechanical properties are affected as compared as a function of sodium hydroxide concentration and treatment of time during mercerization. To investigate the specific objectives of this research are to investigate the effect of hot and cold mercerization on mechanical properties of the fabric, to analyze the results by using central component design of the statistical analysis. The materials used in this study are sodium hydroxide. The lab grade sodium hydroxide is used. The treatment is carried out under tension state on the lab scale machine, and the parameters, the input parameters for this study are sodium hydroxide concentration, temperature, and time of treatment. Three levels of each input parameters are selected. The method, first of all, the mercerization is done on desired time, temperature, and sodium hydroxide concentration in tension state. Then washing is done in tension state so that the shrinkage has minimum effect on this treatment. Then neutralization, drying, and conditioning is done for testing. These are the some of the results that appear after that are after testing. The tear strength of the fabric when treated for different concentrations, the tear strength of the fabrics tends to decrease slightly. It has a minimum effect at 24 Baume and 28 Baume, while when we treat or we mercerize the fabric at 32 Baume, the tear strength is reduces. If we consider the weft-wise tear strength, warp-wise tear strength with temperature, the temperature has some interesting effect, as tear strength of the fabric first generally remains constant or increases from 10 degree to 35 degree, but when we hot massage the fabric, the tear strength reduces. The tensile strength almost is slightly increased when we increase the concentration with time and with temperature. It may be because of the shrinkage of the fabrics that tends to increase the tensile strength of the fabric. If we can come to the conclusion, the tensile strength of a certain fabric increase after massaging, whether it is hot or cold. The maximum tensile strength is achieved at 60 degree, concentration 28 Bombay, and 2.5 minutes time of treatment. So hot massaging generally slightly increase the tensile strength of the fabric. While tear strength is less affected at cold massaging as compared to the hot massaging. So cold massaging is best suited for certain fabrics if we tends to reduce the tear strength of the fabrics. Thank you very much. Thank you for your attention.
Thank you, Dr. Hafiz Afan. It was the end of today's session. Now for the concluding remarks of the conference, I would like to hand over to conference organizer, Dr. Usman Zubair.
Thank you, Dr. Zoeb and Dr. Bilal. Okay, our director, eminent invited speaker, scientific contributors, and the remote participants. On the behalf of our organizing committee, first I want to express my gratitude to Allah on the successful accomplishment of the event that has been now added to the history of National Textile University. This event is a very first of its own kind, where the COVID-19 not only transformed our socioeconomic norms, but also urged the academic and scientific community to thrive in the era of pandemic using the long-awaiting online platforms. Undoubtedly, this event is one of such examples. Here, I would like to thank Professor Dr. Tanveer Hussain, who trusted us and provided every kind of support in this regard. It's worth to mention the unwavering efforts of Dr. Yasser Nawab and Dr. Munir Ashraf, who played a pivotal role in this whole event. The valuable efforts have been added by team members, including Dr. Amjad Javed, Dr. Tala Hamdani, and Dr. Bilal Kader. It would be surely unfair if I will not nominate our IT team members, Mr. Azam and Mr. Shehzad and Mr. Pervez, who contributed to control the events using the online platforms. If I summarize the proceeding of the conference, we have 10 keynote speakers from USA, Australia, China, New Zealand, France, Turkey, and Malaysia, who talked about their past and ongoing researches. 7 talks were delivered by the industry and industrial bodies, including Aptema, Pregmia, iTextiles, Integration Experts, and Hub Power Services Limited. A few talks were given to highlight on untapped potential sectors of textile industry in Pakistan. Various contributors from various institutes have contributed to this event, and they have shared their scientific findings. Just to name a few, it includes University of Monastir, Tunisia, University of Agriculture, Faisalabad, Kunas University of Technology, Ludhiana, Mehran University of Technology, UET Lahore, and GCUF, and many more. 8 researchers have contributed their work by participating in short video presentation sessions. The topic covered were the effect of COVID-19 on our education, fashion, and textile industry, the ongoing research in protective and functional textile in the wake of COVID-19, textile-based composites, nanotechnology and surface modification, sustainability and performance coating, and biomaterials for technical textiles. In fact, this forum provided a wonderful online platform for the linkage of industry and academia, resolving the issues through the mutual discussion and deciding a way forward for the prosperity of industry and ultimately of our country. With this, I want to invite the chairman of the conference, Dr. Yasser Nawab, Director, SCT, National Textile University, for their final words. Sir, it's over to you.
Thank you, Dr. Usman. In fact, as Dr. Usman mentioned, it was really a challenge in this time of pandemic to continue sharing of knowledge. So I congratulate the leadership of NTU, then the organizing committee, faculty, students, participants from industry, speakers from Pakistan as well as from abroad for their participation and to make this event successful. In fact, during the recent times, I have participated in several conferences, and in my view, it was one of the conference with most participation from industry as well as from academia. So I congratulate again organizing team, especially Dr. Amjad, Dr. Usman Zubair, Dr. Bilal Kader, Dr. Zuhaib, all other coordinators and moderators, and especially Head of Textile Engineering Department, Dr. Munir Ashraf. And finally, IT team. I congratulate IT team for their participation. In fact, it was not an easy task. It was for the first time, but I'm very hopeful that it will be the last time. Hopefully, as this is our regular event, so I'm very hopeful that next time we will be meeting physically in the same time of the year, means in March 2022, we will be meeting in international conference on technical textiles, inshallah. So congratulations again, all the team from NTU, all the organizing team. So I appreciate your efforts. Long live NTU, long live Pakistan. Thank you very much.